Right.
Go ahead and reset it. As soon as you see the timer start, we'll kick you on.
Okay. We can start? Okay, cool. Yeah, so hi everybody. Good morning, good afternoon. So it's been a little delayed because I just arrived a couple of hours back, so it took a while to come here. But yeah, I think this talk is mostly about Web3 security and AI, how you can actually use both of this together, and how this can help you to become like a much better in terms of security. So why we're talking about this, obviously we understand security is growing. The problem is actually increasing on a day by day. And it's not only a single, so let's take a step back from Web 2 versus Web 3. We're talking about industries. Like every industry has problems in terms of security. Data breaches happening, money is getting stolen across the industry. So it doesn't matter whether you're building a healthcare product or DeFi product or probably something else. Uh, the threats are real, right? And when you look into geography, obviously we see this region obviously has higher, and then obviously the other region also has. So there are a lot of growth in terms of geography, in terms of domain-specific target. And if you talk about especially the space we are in, Web3 space, we've seen billions of dollar growth in terms of money gets stolen. And when I say this attack is a mix of fraud, scams, technical attack, non-technical, phishing, social engineering, everything. So overall, this actually has a lot of issues, and definitely we know that there is audit, there is compliance and all this there, but then still that's not solving the problem. So what is the next step we can do? How we can create um, various kind of tools for which we can use for our own benefit. So a little bit about myself. My name is Tamagna Basu. I'm the founder and CEO of DataSecure. We are a cybersecurity company. Earlier, I built a Web2 cybersecurity company, financial fraud detection in the banks and all this stuff. And now we are more focusing on Web3 industry. So essentially what, as a company we built, and that's kind of the background of how we ventured into Web3 security and how we envision the kind of future roadmap about this security aspect. So what we see is, when you talk about security, it's a very generic word. And primarily we see there are two parts of it. One part is audit, and another part is monitoring, the fraud monitoring, transaction monitoring aspects, right? And now these two are being handled in two different problem statement. But think from a project sponsor. If you are building a product, if you are actually a person, founder of a new protocol you're building, all you care about is your product secured or not at the end of the day. All you care about whether you need to you have done enough to actually protect your data, protect your users and their data, their value, their money, and their whatever they have invested. So we see that security is a journey. It's not a single problem statement from the beginning till end. So before launch, you need different kind of security like audit, all this kind of vulnerability detection. But post launch, you need different kind of security, which is fraud monitoring and aspect. So with this vision, we have built this product. And again, all these modules we have built are open source. We have actually kind of published it in the public where people can use it on their own. And as part of that, obviously, we partnered with a lot of foundations, and we kind of try to build it as partner solution along with different kind of protocols and all. And let me walk you through my journey, how we got into this space. So the first product we have built something called behavioral biometrics or behavioral analytics. So what does that mean is, this is my encounter with AI, and let's say how I fell in love with AI. I'm a techie, obviously, I'm a developer, builder. Now, 10 years back when I started my first company, we wanted to solve the financial fraud problem for the conventional world. And there is already a lot of rule-based architecture built, and that is exactly what is happening in Web3 world today. If you talk about chain analysis and other various kind of platform which is used, they do transaction monitoring. And the first type of transaction monitoring is define various kind of rules, right? Let's say blacklisted, sanctioned wallets. Are you doing transaction with some suspicious kind of entities or not? Look into the volume of transactions, rug pull detection, whale alert is all about various pattern of detection, right? Is this going through the normal pattern, and do we see a spikes in terms of transactions? But it could be a frequency of transaction, it could be a volume of transaction, etc., etc. So those rule-based architecture is already been in place. It is solving the problem, but still we see a lot of challenges, a lot of frauds are happening. So we looked into that, okay, what is the gap there and how we can solve that problem. So essentially what I realized that, and eventually it come down to identity. Majorly, one is obviously you are actually having a kind of entity which is by nature suspicious. If you're a hacker or probably someone with a wrong intentions, obviously you will steal money. That is there. However, a lot of incidents happen where the identities get compromised. Your identity gets compromised, your wallet gets compromised, money gets stolen from there. Whatever is the reason, it could be a phishing attack, social engineering attack, or maybe a man in the middle where someone sniffed your private key or something like that. So we kind of took that as a challenge, and first level we say how we can protect identity with different other factors. It's not about no longer password, it's no longer about multi-factor authentication. How we can do it. So the first stage we did is we kind of looked into something called behavioral analytics. Now anybody heard about this term, behavioral analytics? Okay. So what essentially it does various aspects. So we kind of started with a very ambitious initiative. Can someone guess which movie is this? Anybody? It's from one of the Mission Impossible movies. It talks about the walking pattern analysis or gait analysis. So the person walks through the vault, it analyzes the walking pattern of the person and sees is this the same person or not. So this is called gait analysis. So there are different kind of AI model you can build around gait analysis based on template, machine learning, and which can actually identify you as a unique individual based on your walking pattern. Because what it says that your walking pattern is unique. This has also been built as a computer vision problem. People have created a lot of analytics on computer vision, which captures through camera your walking pattern and does it. But what essentially we have built a model which actually sits on your mobile. It can be integrated to your mobile applications of web, which actually sits on your mobile, and it captures the sensor data, gyroscope, accelerometer data when you're walking. And based on that walking pattern, it can identify that is it a unique person, same person or not. So we kind of created various kind of model around that. And idea was this can be a very simple SDK library which you can integrate to any kind of wallets, any kind of mobile app where you wanted to protect your identity. So tomorrow, hypothetically, let's say if this model is integrated to your wallets and again, the idea was even if your private key is compromised, someone actually is stolen, and I import it to my wallet, but then because my walking pattern is different versus your walking pattern is different, we can go ahead and predict that this is not the same person who is using. Now there is lot of race conditions, lot of boundary edge conditions are there. What if I'm drunk? What if I'm injured? What if I'm kind of running suddenly? My pattern changes for whatever is the reason. What if over the age pattern changes? Right, aging is also a factor, right? Your mental health is also a factor. Are you tensed? Are you relaxed? Like that. And forget about all this. The biggest problem is mobile's orientation. The orientation of a mobile in your pocket. So there's a lot of things are there. So although we get like 98, 97%, 93 to 94% accuracy, we realize that this is not a scalable solution. Because if as a startup, as a small company, we wanted to address all this problem, this cannot be solved. But the good part of this solution is the data stays in the mobile. So it's basically the privacy is preserved. So that is one of the core fundamental of what we're building, right? Now we move to the next kind of behavioral aspects. We say, there is a simpler aspect also is there called keystroke dynamics, your typing pattern, how you type. That's also unique. So this looks like a quite stable model. We've built it. We've kind of started with a Web 2 world where we have kind of mobile banking, internet banking kind of solution we've integrated. And Web 3 world also we are kind of offering this to a lot of wallet companies to do that. However, the idea is this is a very well researched algorithm. The models has been open source. It's been published. A lot of white papers are there. If you want to kind of build it, you can actually build a model around that. And that is very easy. You can now integrate to, if you're building a wallet or any kind of mobile app, integrate that with you to protect the user identities. Now again, I'm not saying this is going to give you 100% security, but this can give you one extra layer of analytics, which can help you to protect maybe 80% of the current spectrum of attack which is happening there. So this is like how you protect identity on that. Now the other region is gestures. Gestures is another very interesting factor which we didn't realize when we actually are doing this research. But we realized that even on gesture, like how I swipe, how I probably kind of swipe up, swipe down, and holding pattern. I am holding the phone in two hands versus I am a person who hold the phone in one hand. There are different kind of this kind of, we call it like a metadata or like a additional factors we kind of identified and realized that is also can be used for this kind of identity protections. So essentially, this is called the behavioral analytics aspect, where you can create a lot of keystroke dynamics and gesture-based analytics, which help you to give you a lot of protection on your identity level, on your end user wallet or applications. So with this, obviously, we have built kind of a scoring algorithm. But however, as I said, these are all kind of, happy to share all the data what we have, if any of you are interested also. Now, while doing it, and I come from a security background, I realized, what, this looks like the defensive side of fine. Let's see how we can use AI for offensive aspects. So kind of I tried to create a lot of research paper and understand that, although thanks to ChatGPT today is much easier. I'm talking about much back before the GPT world, which got released back in 2020. Can I create a clone of myself using AI? So essentially what I've created is a bot which looks like me, talks like me, it sounds like my voice, and then obviously it responds with the same amount of humor, same amount of, let's say, kind of attitude which I generally respond back. And there's a historical data we have used it. So what it is, this is again an open source project. We have published all the repo, how it's been done, the step-by-step walkthrough which you can use. But when I built it, there was no ChatGPT there, so we used something, the old kind of GPT-1, GPT-2 kind of model which you have built. But the same architecture can be used, which can be integrated with, let's say, Telegram or WhatsApp, using Twilio or any other kind of API. And you can actually create a clone bot of yours, which can be used or misused, right? Used because then you can actually create this as a knowledge bot, as a bot like which you can feed in a lot of your knowledge and help scale your solution in terms of FAQ, support, etc. On the same time, this can also be misused by social engineering attacks or phishing attacks kind of thing. Now, these are some social proofs where some people actually kind of thought that they're actually talking to me instead of talking to the bot. Now, why I'm saying this? Because this was the research I did when during the COVID period. There was nothing else to do, sitting at home, so let's do it. But when I kind of realized this aspect of, let's say, adversarial AI, I've realized that this opened a new era, or new kind of door to a new world of attack vectors. That's what I call it. Now you can be as innovative as possible, create different kind of attacks, and that can actually scale up in a multi-layer, multi-stage attacks, right? And I kind of deep dive into it. Again, these are the few. If you want to take a screenshot, these are the links of the slide, the talk, the GitHub repo, and everything where there's the kind of process we have created. Now what we understood with this is, there are different kind of attacks you can actually simulate and create. Now, when I'm talking about attack, think from a hacker's point of view. We're not talking about specifically Web3 right now, because there are a lot of kind of attack which is very much similar and applicable to, doesn't matter which industry. Or for example, phishing attack it can apply to any kind of targeted organization whom I can target. Now, what is the payload I'm delivering there and what I'm kind of trying to achieve through the phishing attack might differ between, let's say, company to company, or what is my objective. For example, here probably my intention is to steal your private key, versus somewhere else I might wanted to just compromise your account and get your password, right? But essentially what I've realized that now you can use AI to bypass AI. You can use AI to actually create a lot of model which can actually trigger certain attacks, and that can actually kind of make use of various data points to fool you. And essentially, I've created also a workshop around that, and the idea is we can actually do bypass facial recognition, spam filters, bypass any kind of bots, which does a gatekeeper of different kind of channel like Discord and this and that kind of thing. You can do bypasses. So this kind of very scary, but obviously I don't teach it anymore because I kind of found this very scary in terms of this attack vectors. Now we try to create a lot of model around that. Now while I'm doing it, on creating all this kind of model, we realize that the Web3 space growing massive in terms of attacks, and we see this whatever pattern I've been actually thinking, let's say capture or a bot detection, human detection mechanism, which has been used in a lot of Web3 projects to prevent bots to access your protocol, and it's very easy to bypass them. So that is where we actually moved into this and say, okay, why don't you try to defend that? And coming back to kind of what kind of various data points we see kind of obviously billions of kind of money is getting stolen. Even in 2023, we see that its market was not good, but then kind of almost more than almost $2 billion worth of scams and hacks happened. Now, even in 2024, it's been what, like just a couple of months now. Even here also we see that kind of in 2 months time, more than $500 million, 500 million plus, or like $500 million kind of dollar worth of money is stolen. And if you see, these are not the exhaustive list. Obviously, these are like few of the things we can see. Apart from that, there are a lot of other attacks there. If you're from, how many of you are from security background here, if I may ask? Okay, 1, 2, 3, 4, okay. So you guys probably are doing a lot of analysis around that, but when you look into the kind of attack methodology, or we call it modus operandi, right? How it's happened or what exactly been happened here. A lot of times it's not a very complicated attack methodology, and this is very similar to what we have been seeing as an attack vector in the conventional world, which I was talking about. How we can use AI to actually create those attack vectors. So in a nutshell, this is the few top kind of attack options which I've seen, like unauthorized access, which is basically access control was not there proper in different layers, be it smart contract, be it the centralized infra, decentralized infra. That's got social engineering, definitely stealing private key through social engineering attacks and all this stuff. Price manipulation, business logic bypass, and then re-entrancy attack. Now, obviously the question comes, probably re-entrancy attack is one of the most popular one, one of the pretty old one, and a lot of time people say that this attack is no longer valid, or probably is not kind of there. But then when you look into some of other data points, and this is like one of the repository which has been kind of published by like this person, which is a historical chronological list of re-entrancy attack happened across all the entire Web3 world. And you can see that although this is a very popular, very well-known attack, we know how it happens. There are a lot of detection mechanisms there. We still see this attack is still there in the industry, and there is a lot of kind of attack happened. And this repo is good because it actually has indexed all the contract, victim contract, exploit contract, a sample exploit contract which you can use, the transaction histories and everything. So this could be like a repository where you can look into that, how this attack happened. Now, obviously re-entrants have different variations, which you can actually understand and learn more further. But the point I'm trying to say that something which is pretty old, pretty kind of there, is still valid today, and it still works. Now the question is why, right? Is it like the audit not been done properly, or is it like maybe I don't know the answer. Like why? Because to my understanding, a lot of time this is something which is going to be like one of the first things being taught as a smart contract audit security courses, right? How you can identify re-entrancy and what happens. So, but then this is happening. Now, why it's happening is a different discussion, what went wrong there and all this, but definitely it is there. Now, why I'm saying is because something like that is very simple in terms of pattern, which can be trained using AI. So essentially what you could do is there is a possibility you can actually create a model which has this idea of you can train with these various patterns, and that should be able to identify a lot of this kind of options. Now, having said that, obviously a lot of existing tools, static analysis tool also does this kind of pattern analysis. So, so we can actually kind of look into Slither and other tools which has done it. But then the first part was, create a model. So the first stage, what kind of we try to do is actually let's create a supervised model. Now, how many of you are familiar with machine learning? Supervised model, unsupervised model. Okay, got it, right? So supervised model is obviously where we train data, right? So the one easiest option of creating a model is you actually, and this is pretty easy, you can find, let's say, plethora of vulnerable contracts. You actually flag them, do the data cleansing, create, identify the code, and you can do a different level. You can do it on a high level code, static code level, or you can do on a compiled code level. Create like different code sample repository of yours. What is a good code version? What is a bad code? What kind of pattern is there? And this is like one of the exercises we have done where we kind of created samples. We have kind of labeled them in terms of bad code versus good code. On specifically on one vulnerability, like reentrancy, like that, we have created a repository categorized by different vulnerabilities, and we have trained various models along with that, right? So first part is actually the data collection, consolidation, cleansing, and labeling properly, which is any machine learning problem. If you go, that is the first part of it, like data engineering, you may call it, right? So that itself takes quite a while time, because if your data is not been properly structured, your accuracy might get impacted. And this is a continuous learning process. It doesn't happen in day one itself. You get the right data and you can do it. You do something, you understand, then you change your pattern of data. You understand that that might improving your data and all this. So essentially, once you get this kind of data, we tried with various models. And if you know the classifiers, various kind of classifiers are available, from binary classifiers to KNN to kind of decision trees and all this. So we kind of created a different kind of model, and we have done a split, 70-30 split. You can do different kind of splits also, like 70% data used for training, 30% for test, and that also you can do randomly, you can, sampling of that data and all this. So with the data, you actually try to train and test your model, classification model. So essentially, people who are not familiar with, let's say, the machine learning, trend test is nothing but you actually split your data set into halves. Majority of the half you take to train the model, and the other part you use to test it, which is like, looks like an unknown data set to your model, which model hasn't seen it. And then it will try to feed in and see how much accuracy I'm getting. Because the test data, you already have leveled it. You know what is the right and wrong. So you actually try to, based on that, what the model predicts, and you can see that is it kind of predicting in terms of false positive or false negative, or actually the right. So this is something kind of, the first exercise we have done. This is again, we're not getting to LLMs yet, but the simple classification and risk scoring. We also kind of come up with a probabilistic model around that, saying that, okay, I classify this, but what is my confidence score in terms of I know whether it's bad or not. So there are two layers of stages of validation we have created. First level is you classify it in terms of is this vulnerable or not, and second is what level of confidence I have. And you can set a threshold. Let's say that if my confidence level is not more than 60%, I will not consider that as a valid decision, because my model is still learning, right? So first level is prediction, classification. Second level is evaluating based on your risk score. So with this kind of approach, you create a model and you try to test it out. And obviously what you try to do is we kind of integrated that into entire pipeline of your code CI/CD in terms of code deployment in blockchain. So what essentially that means is, let's say you're using Remix, and with Remix you're writing a code, and then you're eventually deploying it on probably one of the EVM chain testnet or something like that. So now you can create a different layer. You can call this model at probably as you create a plugin and an ID level, versus you can do it as a create like this as a like a MetaMask snap. And you can call it from the wallet layer when you're signing the transaction and probably deploying it. Or you can actually create this as a GERD module in base, native to your blockchain kind of thing also create. So essentially, this was one POCs where our vision was create a secured blockchain. So we are kind of natively integrated inside the blockchain, which is actually with the JSON RPC interceptor. And it actually, the moment you try to deploy the code, it figure it out, is this code bad or not? If it is bad, with a certain threshold, it actually kicks you out in terms of doesn't let you deploy the code. So in a nutshell, essentially the idea is first you create a model and you test it out with different kind of data set. And then after that, you try to create various hooks in terms of where you want to call the model to actually deploy, figure it out, it will work or not. So I don't know if it will work. I have a small demo how it works, but let's see. Okay, it's not visible, I guess. But essentially, on the left side is what we have the remix voice, and this is like a sample of re-entrance attack which is there. And on the right side, we're trying to kind of deploy it where the code is kind of get evaluated by the model. And on the down here, if you're not able to, but this is where actually you get a confidence score in terms of what is the confidence score of a decision, is it right or wrong. And as a result, we actually can actually decide based on the score on confidence that is it good or not, should I consider the decision or not. So so again, this is the first part which kind of we have created as a model. And as I said, the overall the vision we had is how do we secure the entire journey of development. Essentially, that was the idea, because as I said, as a project, you need different kind of security and different layer. As a developer also, you will be using it in different levels. So essentially, it's not only about the model, but how you utilize the model. What are the kind of various kind of access point you create around the model to make it very easy, very easily easy to use and to adopt, and very seamlessly it integrates through your development journey. Because one problem we have seen in my experience is security is always considered to be a friction in terms of development, right? So something you want to make it more secure, you actually cut down, let's say, access, which means it's actually a problem. So how do you make it very easy to easy and seamless in inherent part of a development cycle? So what essentially kind of the architecture we propose, and we actually try to say that, you know what, and this is why we reach out to various partners saying that security is a effort of collaboration. It cannot be done once alone. So one side, let's say, IDs should have intelligence in terms of plugins, in terms of something we can create, which can give you static analyzing. That is already there, but then obviously you can create more analytical parameters. Then you can have a pre-commit hooks on your repository layer. Then you can have validators on your wallet layer, and then obviously on the blockchain layer. So this is the first part of the model. But then idea was, now let's do a risk scoring of it, because what essentially we have understood that we wanted to make it very simple. So without getting into how it's been done, we should actually, let's say, can we come up with a very simple risk score, and that can be used by anybody to first identify, okay, is it good or not, and then you go into that, go further to analyze that. So there are various kind of risk scoring algorithms available, which is depending on different kind of qualitative, quantitative, and simulative. So based on various kind of vulnerabilities, one simplest is weightage kind of based algorithm, where you can actually put various weight for your severities, and based on that you can actually create a risk scoring algorithm. So we're kind of, the second level is create a risk scoring algorithm, and that algorithm actually helps you to do a first level of analysis, that is it good or not. Because the one problem with this approach of plugins and this thing is too much of, let's say, text oriented, too much of data oriented, and you spend a lot of time to analyze the data. But the idea is, as I say, we want to make it very simplified. So how we make it very simplified? So first step is, let's create a risk score. So let's say the flow would be like that. There is some entity or some engine or something, some ML or some AI. It first immediately tell you that, okay, what is the risk score? Is it 40, 30, in the scale of 0 to 100, like that? And this solves a productivity problem. You don't have to go to too details of it, and then based on that, you go forward and you understand that if it is too risky, then we can go ahead and analyze it. So this is where kind of risk scoring algorithm comes, where you actually, when you build a model, you should also kind of build a risk scoring around that, because that will be very simple for you to analyze and understand. So with this risk scoring, you kind of create a model, and then the next part is, depending on which layer where you used to, we actually you can actually try to do a indexing and kind of ranking various kind of on-chain contracts. What essentially this will do, this will give you like a profiling of high risk versus low risk kind of thing. And this is where you actually, as a security analysis, you can automate this part. So think of it like that: you create a model which has this risk scoring analytics integrated as a model, and then you create this, wrap it with a crawler which continuously crawl through your explorers or various kind of blockchain, whatever blockchain you want to do, and keep ranking this, the various smart contracts. This could be a contract belongs to a same project, different projects, depending on what is your portfolio. If you're a VC, probably in Insta, you wanted to look into all the contracts belongs to your companies you have invested. So depending on that, you can do so. If you do this as a fully automated manner, then you get the first level of, let's say, report, where it says, you know what, I see kind of, let's say, average risk around 1200 contracts, which I need to look into. And then you go and deep dive. So security, as I say, you have to, there are a lot of times you spend time on something which is not important. So essentially here, what I'm trying to do, prioritizing your work in terms of what is important I need to look for in terms of security. And then you can deep dive and you can do automated further analysis in terms of that. So this is where the ranking algorithm comes, which you can use it. Now I just wanted to one second. Yes. So this part, this is the first part of the presentation, where what we're trying to build is in terms of a kind of a pipeline of overall ML ops or ML architecture, where you not only build a model, but you actually can create a complete end-to-end automated risk scoring platform, where it actually helps you to do a lot of manual tasks which otherwise you are doing today, and eliminate that with this kind of evaluation, so that you can focus on more further analysis on the advanced level of vulnerabilities, which is mostly into business logic and stuff. So this is the first part of the model. So is there any questions, or do you do like later? Anybody has any questions? Okay, so we'll move on. So the other part is, as I say, this is about creating a security stack. This is not about algorithms. Now, there is other tools. So the other part is, obviously you can actually have a lot of this kind of tool you can automate, like using Docker and container. You can do Slither. You can automate that, like a Mithril, or there is a Smart Bugs. There are a lot of other tools are there. But if you want to use, let's say, AI as an engine, you actually have to create a MLOps stack. When I say MLOps stack, as I say, it's AI is all about continuous learning. So let's say I have 100 odd smart contracts or 1,000 contracts today, which has certain kind of vulnerability which I have trained or I understood. But then tomorrow something new attack vector comes. I have to continuously flag and feed that data back into the system and kind of learn it together. So essentially, this is a continuous pipeline where you create a data lake first, where you keep pushing the data, which could be flagged, it could be labeled, it could be like unsupervised, and then with this data, you continuously train your model. So what essentially we have done on this is we have created an LLM, large language model, and what it does, and thanks to ChatGPT, obviously, it's nowadays even much easier, where you can actually do a kind of model by yourself. So there is two things I want to show you. So can you see this? Yeah, let me zoom it. So, so let's say this is called LLM bot. I'll just quickly show you how this can be built pretty easily, and you can do it. So again, first part is you need data. So what essentially you do, first you create your data set. What essentially that means is, um, okay, let me explain you the process, and then probably I'll try to show you how it's been built. So first I have, as I said, an initial research classification model what we built. We anyway have labeled the data. So we have created a repository or index of data, which has, let's say, hundreds to hundreds of different kind of vulnerable smart contract with specific vulnerability, reentrancy or any other kind of vulnerabilities are there. So we've created the repository. Now in ChatGPT, you can create a bot where you can feed in the data. So you can actually say, you know what, you now gonna be a smart contract audit bot, and here is my data point. So we have created, so we have indexed and crawled through various kind of vulnerable smart contracts, and also we have created what is that vulnerability, what code part of the code has that vulnerability. We have created that as a data, and we feed in that data to the GPT saying that, you know what, this is what has been sampled, where you can see that how this has been exploited. That's number one, first stage. The second stage is pull out all the audit reports from all the, everything is public, right? Pull out all the audit reports from all the companies and whoever published the audit report, right? And say that, you know what, this contract, this is the contract source code, and this had this. These are the vulnerabilities which it had. Why don't you kind of learn from that? And then you feed in all this data back to GPT, where there's a bot creation flow, and once you feed in all this data, eventually this has the intelligence where you can actually say audit this smart contract, and it should be able to do a smart contract audit there. So let's see if I go to. Let me try to go to, let's say, not Morph, maybe Polygon Explorer. Okay, let's go to Polygon Explorer. And let's say I go for, I don't know, top tokens, something. I'm just giving you some random thing. Let's say this is the code. I go to the contract, and obviously this, a lot of time this contract has multiple files, but let's say this is the contract. I'm just giving you a very simple, this is a very simple prototype. You can copy paste the code, and what I can do is you can say that audit this smart contract. I'm going to paste the code. So what it is, it will do, it has actually kind of has intelligence of how it has been done, and then it actually can run and it can tell you, yeah, so what are the problems I can find and all these things, it can actually do it. So this is how we do, and this is done using the GPT bot creation feature. So actually, if you don't know ChatGPT, you can actually create your own bot. So you can actually create, okay, this is not the one, but okay, create here. From here, you can actually create a GPT builder. This is the one. And so you can say that, you know, so like that you can create a smart contract basis. So again, you have to try it out. Obviously, it's not that always 100% perfect, but then once you do this, you create, and then in the configuration section, here you can go And here you can name your GPT bot. You can say, let's say I want to create, let's say, and instructions are there. Um, so you can create various kind of prompts, and eventually here there is a knowledge section. This is where you can upload files. This is where actually once you label the data, the one I've created, those kind of labeling data, which I've shown on my previous slide, you can upload those data here, and once it has those intelligence, you can actually create your own bot there. So this is one part, and once this has been done, you can actually keep uploading the data later on as well, but this can actually give you a very simple chatbot which can create and which can analyze the quality contract and everything, and then you can create API around that and all this stuff. Last but not the least, there is also a kind of GPT based yes. So this is the most recent report, has been published on February 20th, just 5 days back, which actually is a very good reference if you are trying to build your own automated AI based, let's say, audit bot. What essentially they have evaluated kind of lot of kind of model, and with this there are primarily 3 parameters which you look into: vulnerability detection, code parsing capability, and then POC writing ability. Because the other challenge in kind of smart contract audit is not only detecting the vulnerability, but eventually we have to create a POC. Especially if you're a bounty hunter, if you're doing bug bounties and all this stuff, you need to create a proof of kind of POC code which will able to exploit that and show you that this is exploitable. So how do you kind of not only find vulnerability but create an audit? So essentially with this, you can create various kind of model, and this is a very good reference where we managed to create a kind of a smart contract, a good chat GPT prompt which helps you to create a smart bot which will give you a more efficient result. So so in a nutshell, thanks to GPT, there are a lot of things which is much easier. But then, if you have to do it in a basic fundamental way, you have to start from the beginning of collecting the data, labeling, cleaning the data, and then creating a lot of models on your own. If you want something, you have access to ChatGPT or ChatGPT Pro, you can create your own bot like this, and that can also help you to do a much faster analysis. Now, this analysis was able to create and identify a lot of good vulnerabilities, and it is much scalable, obviously, because they can do audit much faster. So I think in this research they are able to audit like I think 34,000 smart contracts in quite a faster time. I don't remember exactly, but they have published the data report here. So with the interest of time, I'll stop here. But this is a very good reference of how you can create a much efficient LLM model for audit. So yeah, I think that's pretty much what I have. Yeah, thank you so much. If you want to connect or talk, happy to get connected. Yeah, later after the talk. Thank you.
And you can just plug in right here. We got HDMI or the USB-C adapter if you need that.
Yeah.
And that should be it. And if we have any Yeah, soon you'll get your sorted out on that.
All right. Hey, everyone. My name is Luis, and it's amazing to be here. I hope everyone's having an amazing day. It's really sunshiny in Denver. I'm Luis. I'm the CTO at Mintbase, and Mintbase has been working in the NFT space for 5 years, about 6 years now. And we've been working with the goal of making NFTs useful for a wide range of applications. And since last year, we started focusing a lot more on onboarding and easy-to-use tooling for developers. Today's presentation will be about a lot of our learnings over the past year working with AI and how we're thinking about the future and what it means to bank AI agents. So for a couple of weeks, a few weeks ago, I had way too many notes lying around my computer, too many bookmarks on X, and I was like finding it really hard and struggling a bit to figure out where is AI going and what are the things that we should do or like how to worry or what are the things we can do at the intersection of crypto and AI. So in this presentation, I'll be talking a bit about this thesis, something that we at Mintbase are like shaping, and I'll break this into 3 main parts. And yeah, towards the end, there's a small workshop for different experience levels. And yeah, so I think that AI will make UIs and APIs widely available and affordable. It will become the predominant force in driving internet activity, but it won't do anything meaningful until it is banked, right? So before we start diving into this, it's quite important to make some definitions here. When we're talking about UIs, we're talking about user interfaces, so the interface between users and software. When we're talking about APIs, we're talking about software, the interface between software and software. And recent advances of large language models showed us that it's possible to build programs that kind of generate UI, that figure out how to make API requests and all these things, right? So let's take a look at a few examples. Oh, sorry, before that, an AI autonomous agent, when we're talking about those, we're talking about systems that are designed to independently perceive, decide, and act in complex environments to achieve goals without human interaction. There are a few examples of those. We have self-driving cars, automated trading systems, but we'll be focusing a bit on virtual assistants or, with the advent of ChatGPT, we're all like able to touch these things on our daily lives. So we'll be talking a bit about those here. All of this is from the perspective of building the Mintbase wallet. We started with the goal of making it very easy for onboarding users. We introduced meta transactions, account abstraction, human readable names. And we did all that because we wanted to provide a good user experience to people using our AI chat playground that we started last year when we started playing around with ChatGPT. And yeah, so again, like this presentation will be done through the lens of building the wallet and why the wallet is becoming an important thing for us. So starting with the first part of the sentence, AI will make UIs and APIs widely available and affordable. There are a few examples of this. There's Rabbit.tech. They recently announced this device, R1. And it's powered by what they called a large action model. So it's slightly different from a LLM or a large language model, but it was trained to understand and execute commands, essentially replacing the need for users to interact with every individual app or website. And this is done with this device. It can complete tasks through natural language requests. So you can say, play this song by this artist, and it will figure out how to interact with the apps to make that happen. Another example of commoditizing UIs, we have v0.dev by Vercel. So essentially, you can ask, I want to build this amazing website or landing page for this use case, and it will generate React code with Tailwind and all of those good things. And you can interact with the chat and ask changes on particular parts of your screen, and it will adapt those changes and improve the UI for you. So it's becoming very easy to create these UIs. And then we have Mintbase. Again, we started playing around with ChatGPT plugins back in May last year. our goal was always to make it easy for people to interact with crypto, with blockchain. And we did this to kind of like figure out what are the things that we can use to let users just ask for things and have, you know, the AI like complete queries for you or generate transaction payloads that you can submit and that you can sign and submit. So we built plugins like this, and I'll explain a bit more towards the end of the presentation. And then, of course, there's GPT. They're introducing this amazing marketplace for agents. You can create agents with very specific goals and roles and with access to many different tools. So recently, they also announced that it's possible to now talk to multiple agents in one chat. I think this is really interesting because it goes in line with a new paper that came out recently called "More Agents is All You Need." And essentially, the LLM like performance scales as you have more agents to perform, together to perform tasks. So this kind of implies that the popularity of multi-agent frameworks is justified. So the second part of the thesis is AI will become the predominant force in driving internet activity. And I was doing this presentation, like prepping for this a few days ago, and one of my coworkers kind of like asked, yeah, but what are, like the things that are driving the most website traffic today? He kind of like suggested bots are driving most of the website traffic. I looked it up, and apparently it's kind of like half-half. We have both humans and bots kind of share roughly equally, the amount of visits humans do. And this was quite surprising for me. But when we look at bots and agents, and when we think about these things, they kind of differ from like very fundamental levels. So you have bots are designed to complete tasks, very specific tasks and repetitive tasks, while agents kind of like operate in more dynamic environments. They can work towards self-defined specific goals or like human-defined goals. When it comes to learning and adapting, bots typically do not learn or adapt independently, while agents have this capability to learn over time. And when we look at decision making, generally bots have like rule-based decisions, and agents can have like independent decision making going on based on their cognitive skills. So I think that we're looking at a new type of consumer. It's still kind of not easy to kind of define this, but we're starting to see that these things are like starting to grow into becoming a new consumer, like interacting with multiple websites. Could be from a human requesting those things, or the agent itself kind of like figures that out and wants to access a website for some reason. So one of the cool agents that I've been playing around with is the Miracle agent. It's not a like a new thing. The paper came out 2 years ago. I wasn't still too much interested in AI, but now like I'm starting to see the relevance. And essentially, they work with large language models, and they kind of blend the capability of large language models, external information, and the reasoning abilities to perform tasks. So the Miracle agent or system is designed to interact with humans in natural language ways. So you can say, I want you to do this or that, and internally it will go in a loop, like doing observations and having thoughts and using external tools that you can give them. And once it figures out like the final answer, it will just answer. It will just answer. So. How we're thinking about this within our wallet is through this. We're launching this very soon, but it's what we call smart actions. So essentially, these are prepackaged prompts, could interact with multiple tools, but essentially, it's a very simple way to let users, experience crypto. I think we've been doing this a couple times, like giving prompts that people can just like use to mint their first token without having to go through all of the different steps for creating an account and all of those things. And we're building these sort of agents with several capabilities and tools. So here's an example of a run. I asked it to, this is, again, through slides. I wasn't sure if the internet would be great here, so kind of like made slides to show you step by step how it works. So you can ask like mint a Denver image NFT, and then it initiates, right? The first thing it figures out is that I want an image, right? Because I didn't input any image. It will figure out how to generate an image. Generates the image for me. It also uploads to Arweave behind the scenes. Then it will figure out like what are my account details for many reasons, maybe to figure out like if I'm connected to mainnet or testnet or the network I'm connected to. And then it will generate the transaction payload. And once it's done, it will prompt me a review transaction. I can still make sure that everything looks great, and I can hit approve, and there you go. There's an NFC minted, all using natural language. So this is kind of a joke now, but I think that if every year the traffic coming from AI agents doubles, we'll be seeing like exponential growth, and eventually in like 5 years, agents will take 80% of the traffic on the internet. But again, don't quote me on this. I'm not sure. So and now coming to the last part of the thesis, any of this will be meaningful until we give access to finances or a way to transact to these agents. So I saw this on Twitter the other day, found it quite funny, because I was thinking about this, and it feels like people are starting to realize this. Yohei was the creator of Baby AGI. If anyone here knows, Baby AGI was kind of like one of these multi-framework, multi-agent framework that came out like last year with AutoGPT and a few others. And essentially, yeah, an LLC for every AI agent so they can open bank accounts and stuff. I'm sure that will be interesting. But this contrasts very well with another tweet I saw a couple of months ago. So imagine an AI agent waiting like 2 days for a wire to clear. This is not going to happen. Agents will need a way to transact globally with instant finality. And we can think about a few of the alternatives we have. There are, we could give them bank accounts, Stripe API or similar payment providers. They could be using crypto accounts and wallets and all of this. Or we could create like a new type of protocol outside of crypto, outside of everything. But this, so I try to put this into a chart, and I don't think it's feasible. Like, I put this into like the Web 2, Web 3, and then effortless and elaborate. And I'm going to try to explain here. So for each one of these, there are pros and cons, obviously. I think for banks, it's kind of elaborate because, again, it's good that they have widespread acceptance, but there are fees, minimum balances, slower transactions, and there's limited accessibility as well, right? So there are regulations and maybe some financial literacy requirements. So I don't think banks would suit very well for agents. Then when we look at Stripe, again, it's very easy to integrate. There are global payment options, and it's quite secure. But then again, there are fees, slower transactions. When we look at crypto accounts, well, we have instant global transactions. We have a permissionless network. They support programmable money, smart contracts, and all the good stuff. But there's still a bit of regulatory uncertainty, and I'm not sure where this would put agents in. And for a new protocol, I'm sure there are like many ways to make this, many ways to customize a protocol that suits agents very well. You would probably have like full control of the protocol, but then there comes like adoption challenges, development and maintenance costs, and the regulatory compliance as well. So I think the wallet, and again, I'm here representing Mintbase, but I think there are many wallets that could be used for this. So today, we started powering all of our wallet features with AI. So you can ask questions, you can do transfers, mint tokens, buy stuff. All of that is AI powered. And you can think of it like this, right? So you have humans interacting with the wallet, you have AIs interacting with the wallet, and underlying you have the blockchain and multiple providers like Stripe, Ethereum, Near Protocol. And then we also are introducing AI providers. So we're giving a unified interface. If you want to use the like Mistral model from X provider, you could use that through our wallet. And this is changing a bit how we're building things. So we started a new page called templates, and I will introduce it later. But this is an example of a template. It's very easy. It's easy to bootstrap from this. Essentially, it lets you mint a token, using any replicate model. And this is kind of like how the code looks like. There are multiple pages, a lot of code files. And our ambition is to move towards this future, right? Where a simple link could be like an UI redirect or just a redirect or an API fetch. And you would be able to pretty much do the same thing powered by AI. All of this also with an easy integration for any web application. We followed the OpenAI spec, API spec. I think many providers are doing the same. And so it's very simple for you to swap your OpenAI endpoint or any other endpoint that follows the same spec for this one. And it integrates very well with the AI package by Vercel. So yeah, templates. This is a hub. If there are developers here, it's very nice. It's very easy for you to go there and just pick one template. We have a couple now. I think we have about eight. All of them try to give like a very good user experience to users and developers as well. So yeah, give it a try. This is one example. And for ETHDenver, we also have bounties up. We want, we're asking for the NFT loader by LangChain, so that supports for LangChain. So you could like input some NFT like contract address or token ID, and you could load that information into your agent workflows, and also like an original template. So if you want to get your template up in our templates page, we're happy to fund that. All right, so I think we still have a lot of time here. I'll just do a quick swap to extend display. It's good now. All right, so if you, no, not this one. Yeah, I'll give it a few seconds if anyone wants to access this. All right, and once you do that, this is what you should be seeing now on your computer or cell phone. But yeah, so I prepped this like with with different experience levels. I'll start with the easy one since we have still a lot of time. And essentially, the easy one is for getting started with Mintbase. And I want to show you how easy it is to create an account with the Mintbase wallet. I'm already connected here. Yeah, so let's create an account. I could use speaking at ETHDenver. Yeah, nice. So now it prompts me passkey. We're doing this so it's easy for storing safely your private keys. The near account system supports multiple private keys, so you can kind of like revoke this key if you don't feel safe anytime you want. And then I'll use my fingerprint, screening my account. Hopefully it doesn't break. Awesome. So I created my account. It's ready to use. You see, 0 funds. And now going back to this, and hopefully some of you are doing the same. And the second one is minting my first token. So we provide 2 ways to do this. It could be a selfie. I'm going to use both. Minting a selfie, this is what we call Minsta, which is an application for minting selfies and pictures, and very easy to use. It uses Matter transactions, so we sponsor all of the minting coming from this application. So let me log in first. Many accounts. Yeah. All right, I'm connected, and I'm going to prompt this. It's kind of weird. All right, so now minting is processing, uploading to Arweave, and prepping for my minting. Might take a bit. I forgot to mention, but we're also generating the image description with Lava, which is a model too, a vision model. So this takes a bit. If no one's accessing the model, it takes a bit to load the first time. All right. So there's an error there, I'm sure, but it looks good. Let me try to hit. Man, many accounts. I'm getting doxxed. And once it's done, it should take a minute or so to pop up here. I'll hit refresh. Yeah, it might take a second. Or not, not sure. Well, we'll see. So going back to GitHub, I lost it. All right. So going back to GitHub, we were on this one. Let's try to hit smart actions while we wait for the other one. Maybe it failed for some reason, but I asked it to mint a cat NFT. So now it's getting my account details. Awesome. Generated the image cat. And here's the payload. So now I should be able to hit approve. And oh my god, many accounts. All right. Sign into transaction. All right, so it was minted. I can check my NFTs. Oh, all right, so it took a second to load. Here you can see my selfie, and here you can see the cat that was generated by AI and all that stuff. And you can see that my account holds 0 balance, so this is the magic of meta transactions. It didn't load up here. What? Oh, it did, nice. I see some of you there, I think. Awesome, thank you. All right. What else? So now, like, if you guys want to go through this, there's create drop. It's also a way for you to create your token for free, share that with anyone, with an audience, maybe share that on social media, and you get pretty much the same technology behind the scenes. But now I think we still have time, so let's go through the medium experience level. I see some people with computers, but I'm not sure if you guys want to run this. It takes a bit of setup. I'm not sure if the network here is great for that, but save this, do that later on your own. But yeah, you can set up, install Ollama. Ollama is a hub sort of to download models and run models locally on your computer. There's a bit of, yeah, there's some system requirements here. So at least like, generally like recent computer would be able to run models, especially the smaller ones. And then once you're done with that, you can create an account with a Mint-based wallet. And let's go to the third step, that is setting up your autonomous wallet. So it's an autonomous agent that acts as a wallet. But yeah, I already done all the setup, but like you can git clone from this branch, from this repo. Everything is on the link I shared earlier, and then set up some environment variables, and you'd be able to start running your autonomous wallet. So I already done that. Let's go. You can see that it's running here. You can prompt. Not this one, sorry, it's this one. And yeah, let's do Ollama. Is it too small for you guys? So Olama list, show me all the models I have installed on my computer. And since I'm already running Olama, I don't need to run that. And what I could do now here is show you a bit of the code. So yeah, this is using something called MicroAGI, which is, again, another framework for you to set up autonomous agents. I built the wallet agent, which is very simple. You can see that it's a Miracle type of agent. It reads the context and execute tasks using tools to interact with the wallet. And then the backstory is that it is a wallet agent with the ability to interact with the Near protocol blockchain. Your job is to read the context and execute tasks related to the wallet. Super simple to set this one up. The provider is Olama, so everything is running locally on my computer. And then I give it access to very simple tools for the wallet. One is to get the connected account. So you can see that once the agent needs to access to the connected account, it can just use this tool. The other one is to get the account balance. And then the other one is minting a token. So you can extend this indefinitely for all of the tools, all of the wallet capabilities you want to support for the agent. So if everything goes fine, should be able to run start. I'll just delete the last run result. And let's run this. We'll prompt a lot of logs. That's fine. And I gave it a few tasks. So the first task is answer the following question, what's the connected account? Then the second task is answer the following question, what's the balance of the connected account? And then I asked it to mint a token. These tasks were created by me, but you can imagine like an autonomous agent running autonomously and creating tasks for itself. All right, so I think we generated a result. Let's see. We can format it. And each one of these objects is the result of one task. So the connected account is microagi.testnet or microagi.dev.testnet. That's fine. That looks fine. The balance of the connected account is 69.76 near. And then for the last task, which is mint a token, it seems that it could not find context related to the role. So maybe we need to run again. This happens. I think it failed again. It definitely failed again. Yeah, the last one is a bit trickier. It's also not as powerful as like something like ChatGPT, since it's all using my computer resources and it's a small model. But let's do one last try. Yeah, it seems it generated, oh, wait, don't save this one. Well, yeah, either way, you could run this on your computer, figure out like why it's failing, and it's just a cool concept, and I think it's very accessible. So yeah, I think this is it. Thank you. Should I close this or close this? Should I close this?
Got one. Hi everyone, my name is Viraz, and I'm a smart contract engineer at Shell Protocol. And today I'm going to be showing you how can we make any DeFi dApp atomically composable. So we're going to talk about what are the current UX issues that exist with the DeFi ecosystem. And then we're going to dive into the code side of things and just dive in how can we explore the solutions that we can implement to sort of solve those UX problems that we have. So to start off, first of all, how many of you guys use DeFi dApps very regularly? Just a raise of hands. Okay, so yeah, this is going to be fun. So this image sort of aptly describes how the current state of DeFi overall looks like right now, where we can see that we still have a bit far in terms of getting to an ideal DeFi UX state. So it's still a bit far off from that, and there's a bit difference in terms of how we speak about it and what do we actually see in terms of UX in different DeFi apps, right? And I mean the ideal vision would somewhat look like this. Besides, please ignore the approval transaction, which is a forever pain that we have already, which we have. And the second transaction, just focus on that. So that's the ideal UX state for DeFi should look like, where you can do multiple complex operations in just one transaction. For example, you can just let's say if you have wrap BTC, so you can use that and buy an NFT in just one transaction by doing in multiple operations like you see. But the reality is far from this because the reality is something like this, right? Where you have to do multiple transactions to achieve this, and which involve multiple approvals, switching between different websites, a lot of high gas costs, and of course MEV risk as well, especially with AMM related operations. And we at Shell have sort of been working towards a solution for this, where we have created a set of smart contracts and differentiated the accounting layer and the business logic layer. So you can basically have a track at improving UX that way, where you don't have to put everything inside one contract, and you can break that into two parts and make it more modular. And so you have like two different layers. One is the accounting layer, and then you have the business logic layer. And the accounting layer that we have developed is called the Ocean, which is a ERC 1155 contract, where users can basically interact with that, and the business logic which does all the computation can just be a black box for the users, right? So the idea is that users pass in an array of structs to a smart contract method, which in a protocol definition we call as interactions. So interactions are nothing but sort of batch operations that users can use to do these different primitive related operations. For example, swap, like adding or removing liquidity, etc. Right? And we'll dive more into it as we go along. So this is a short UI snippet that we have from our current dApp, where we have a couple of examples. Where the first example we have is a multi-NFT swap, where you can swap multiple NFTs for USDC in just one transaction, right? And and again, this makes it, this shows how composable your dApp can be, where you can minimize user clicks, and do everything complex in just one transaction, right? And so this is one example where you can swap NFT for an ERC20 or vice versa. And the other example we have is an LP to LP swap, right? For example, with different AMMs right now, if you have to migrate your liquidity from one pool to another, you have to do multiple transactions, right? But with Shell, in a way, you can do all of this in just one transaction because of the composable smart contract architecture that I just talked about. So with composability, we have realized that to gain more user and dev adoption equally, you having a composable system gives you power to basically integrate with multiple DeFi protocols without a lot of code complexity, right? And what this does is helps you to create a system where you can which can be a one-stop shop for DeFi, basically. So a user, for example, a retail user who's sort of just venturing into Web3, they don't need to know about multiple protocols or how different protocols work. They can just come to one platform and do all their operations there itself, and all the behind the scenes stuff can just be a black box for them, right? And which reduces complexity and sort of simplifies the user experience, and which in turn would help us to get more users in Web3 in a way for DeFi related use cases, right? So composability is sort of directly proportional to these omni DeFi dApps, where you can, like I said, just do multiple operations with just one interface, rather than having trouble in terms of switching to different handling different tabs, switching to different websites, etc., and also reduce gas costs a lot, right? So to do all of this, to sort of achieve this vision, we have sort of started working working on this and developed a set of smart contracts called the adapters, which is nothing but a middleware between the Shell contracts and any external DeFi contract like Uniswap, Balancer, or Curve. So the idea is that behind the scenes, the Shell contracts communicate with these adapters, and then these adapters call these external smart contracts, and hence they are able to compute that result and perform any operation, for example, a swap or add in liquidity, etc., and then just communicate that back again to the Shell contracts. And that's how the cycle works, right? Where there's a two-way communication between the ocean, which is our accounting layer, and the adapter, and then there's a one-way communication between the adapter and the external contracts, and that's how the whole user flow works, which we'll dive into more as we sort of go along, right? So this is just a simplified version of the diagram that we spoke about earlier, right? Where there's a user who calls the ocean, right? And there's a method called as compute and do interactions, right? So there's a method in the ocean contract called do interactions, which states in an array of structs, right? And that strut is called as an interaction, right? Like I mentioned earlier. So you pass in an array of different interactions, and interactions can be basically start off. The user flow sort of starts off by first a user locking in their underlying token. It can be an NFT, it can be any ERC20. So they lock in that ERC20 token, and they get in a ERC1155 token in return of the same value, right? And once they do that, then they pass in the second interaction, which is nothing but the business logic based interaction, where they can let's say add liquidity or swap tokens, right? And then at the end, once that's the middle interaction, and the last one would be to unwrap the token. So for example, if I want to swap USDC for USDT, so first I'll wrap USDC. The second interaction will be to swap the USDC, the shell wrapped USDC token with a shell wrapped USDT token, which is again the ERC1155 tokens that I spoke about. And the third interaction would be to unwrap the shell USDC token to the underlying USDC token that you get, right, at the end. So you can basically start off by one token and get the other token back by in just one click. So that's the whole idea, and I'll dive into the code base now. So you guys can, in case you have your laptops, you can clone this repository, and we can. Anyways, I'll be showing over the over this presentation. Like I'll dive into the code, and if you want to follow along better, you can clone this repository and just dive in with me. Yeah. Yeah, so I'll just dive into the code now. Yeah. Yeah, I hope this screen is visible to everyone, or should I'll probably make it more. Yeah, so the idea is this is what interaction basically looks like. And let me know if you guys need me to show the GitHub link again. So you can basically go to, you can search Cowrie Labs on GitHub, and you will find a GitHub org link. And the first repository that you see, it's called ETHDenver Adapter Workshop. So you can clone that. This is the link. I'll just keep this link open for a bit so that people can clone the repository if needed. Yeah. So yeah, so it's called Cowrie. The GitHub organization name is called Cowrie, and you can just go to that. And the first public repository you'll find would be ETHDenver Adapter Workshop, and you can clone that. And there are like steps in the README where you can first run yarn, and then I'll just probably go over that once. Yeah. So you can clone the repository, and then you can first install all the dependencies with yarn install. And you can just run forge-b to install the Foundry-related dependencies. And that's it. And I'll just dive into the code, and we can go over the tests and the code side of things now. Till this point, just wanted to check in with everyone. Till this point, do you guys have anyone has any queries that we should go over before I dive into the code? Because it's a workshop, so I'm just making sure if I should. Okay. Okay, I'll just dive into the code then. Yep. Yeah, so this is the starting point basically where this is the interaction strut that I was sort of speaking about, right? And the first thing we have is a bytes parameter in the strut that we pass into the ocean, which is called interaction type and address. So this is nothing but just an encoded form of the interaction type, which is an enum, and the address of the external business logic contract that you want to interact with, right? Or the ERC20 token, in case you want to wrap or unwrap, it's the address of the underlying token that you want to wrap or unwrap. Or in case you want to do a business logic operation, the address here is the business logic contract address, right? And these are the interaction types that you can use, right? So we have a wrapping of ERC20 tokens, wrapping of ERC1155 tokens, and 721 tokens, right? So you can, the ocean is compatible with all these tokens, token types. So that's the wrap transaction types, and then the unwrap types again are the same. And then there are the compute output amount and compute input amount types, which are basically your business logic related interaction types. So compute output is basically just that you have an input token that you're passing into the ocean, and you'll get a specific amount of output token depending on the value of the token that you're providing, right? And so it's just a buy and sell operation in a way, right? And now we'll dive into what's the method that we call on the ocean, right? Yeah. I'll need to, yeah, I'll just dive in. Yeah, so this is the smart contract method that any user calls on the UI. For example, if you're interacting with the shell app, which is called do multiple interactions. So as you can see, this states in an array of interactions of the interaction struct. And then it has IDs, which is just basically the ERC1155 token IDs that we use to compute, to keep a track of the accounting for the ERC1155 wrap token balances on the smart contract, right? And then the third part is, of course, the user address that's interacting with the method, and which will sort of receive the tokens at the end, right? And then what happens is then this contract will basically call the business logic contract depending on the address that you pass in the interaction type and address bytes parameter that I mentioned, which is this. So we basically decode this, the value that you pass into this argument, and based on that, the address that we get, there is a then basically we call the primitive, and the primitive basically then, which is the adapter in this case, and the adapter then basically calls the external contract to communicate and then do that operation that the user wants to do, right? So here is the adapter address that I was talking about, which is this, which is called ocean adapter. It's an abstract contract that different adapters basically inherit. So the idea is that you call in the compute multiple interaction, the do multiple interaction method on the ocean, and the ocean basically calls the compute output amount method that you see here, right? Where you see three operations basically happening. So the first one is because in order to deposit the underlying token to the external contracts, we'll need to unwrap the token first, because like I said, when you interact with the ocean at the start, you will need to wrap your underlying token into a shell-based, into the shell ERC1155 token, right? So because the token is wrapped, so you'll need to unwrap it first. So this is what we're doing here. We unwrap the token first, and then we call this primitive compute output method, which basically calls the adapter, and calls the adapter specific external contract method, and that this method basically communicates with the external contract to do a particular operation, for example, swapping or adding liquidity, etc. And then you get a result back from this method, which is the output amount, right, basically. And then you basically wrap up the output amount again into the ERC1155 form, right? And that's how you're able to, do basically wrap, you start off by one token and you end up with another. So this is the whole process in terms of interacting with the external contract. Now I'm going to dive into this primitive output method, right? So here is an example which we recently sort of shipped, which is a curve two-pool adapter where we are interacting with a curve pool having two tokens, right? And in this case, in this example, I'll be taking an example of a USDC-USDT pool, right? So, yeah, so this is the smart contract method that I was talking about in the previous link, right? This is the method that's been called, and as you see, what happens here is, now the first operation is where we convert the decimals, right? So the idea is that ocean words, when we wrap totons, the totons are wrapped into a 18 decimal form, right? And now when you unwrap it, right, we'll need to convert the decimal format into the underlying token decimal. So for example, if you are dealing with USDC, right, and the shell token now, shell version of the USDC token has 18 decimals, but USDC, the underlying token, has only 6 decimals. So you need to convert those values in terms of the decimal of that particular token, right? So this is what happens here. We get the raw output input amount. And then what we do is, because an AMM can have 3 operations, right? It can be a swap, it can be a deposit, or a withdrawal. So here we determine what's the compute type, right? And once we do that, we basically, based on the compute type, we call in the curve smart contract methods. So either it can be a swap, or it can be, a user wanting to add liquidity, or like removing their liquidity from the curve pool, right? So that's how it works. So first we sort of convert the token decimals, then we determine what's the compute type, and then we call the external smart contract method. And at the end, we get the output amount, and then again we convert the decimals back into the ocean specific decimal amount, which is 18 decimals, right? In case the output token is less than 18 decimals, right? So we convert that back to 18 decimals, and we return this output amount. That's it, right? And then you, like I said, then you just wrap this token, right? So now what I'll do is, I'm just gonna, I'll walk you guys through a test, right? Just give me a sec. Does anyone has any queries up till this point? And we can go over, and I'll move forward accordingly. Okay, no worries. Yeah, so I'll just show you guys how sort of a test looks like in terms of implementing this and testing this in the real environment. So we have these. Yeah. So we have these 4 test suites that we have created, right? In terms of testing out these adapters, where we can fork the real environment in this case, because our contracts are deployed on Arbitrum. So we use Foundry to fork the Arbitrum network, right? And basically run all these smart contract tests for these adapters, right? And in this case, like I said, the example that we're taking in is USDC and USDT, right? So so there are like 3 fuzz-based test scenarios, right? So we start off by a swap, right? Okay, I'll probably have to what this. Okay. Yeah, so we start off by a swap test, right, where we've just taken a Boolean argument in terms of which token that we want to swap and the amount that we want to swap, right? So and based on that, we set the input and the output address accordingly, right? And now I actually had a to-do here, because I wanted to for us to sort of code the test scenario. But I can probably just rewrite it and just go over the interactions that way. Yeah, I'll probably do that because not a lot of people have their laptops with them. So probably it will be better for me to just get the code back in and then just go over the test code. Just bear with me for a couple of minutes. Oh, sorry. I'm just doing it for a couple of minutes. I'm just getting the code back in. Shit. Yep. Thanks for bearing with me, guys. Yep. Yeah, so I've added in the missing code that was there, and now we'll just dive into the test, right? So like I said, this is where we start off by sort of creating these interactions and then calling the Ocean smart contract, for example, to swap USDC or USDT for the other token with the help of Curve, right? So the idea is to have a interaction array of 3 items, right? And the first item, like I said, is basically a wrap ERC20 interaction. So where we first wrap the token that we have, which is either USDC or USDT, depending on the fuzz input that we get, right? So we do this, and as you see, we have a property here which is called specified amount, where we pass in the amount of the tokens that we want to sort of swap, right? And metadata, we don't need any metadata here because it's just a wrapping operation. So we just do this, right? And then the second interaction is basically the compute interaction, where we compute output amount interaction, where we define the input token that we want to swap and the output token that we want to get, right? And the amount that we want to swap in for, right? So as you can see, here is the compute output interaction that we are passing into this to the interaction type and address argument that we discussed before. And this is the address of the adapter that I just went over, which is the Curve tuple adapter, right? So basically, we sort of concatenate both these values and then create and get a bytes 32 result, right? Bytes 32 value, which we pass into the strut. And the input token, again, is the shell-wrapped ERC1155 ID. And the output token is, again, the same for the output token address. The specified amount, because the Ocean has a check where if you pass in the maximum amount, it will automatically just take in the amount of the balance that it has, right? That you want to swap in the previous interaction. So it will automatically just take the amount as this amount that we passed in, right? And now the last interaction is to unwrap that token, right? So once you do the swap, the last operation that you'll do is to get the shell-wrapped ERC20 token, burn that, and then get the underlying token back to the user, right? And that's it. And we just call this do a multiple interaction method. And we are able to see that we have a check here in terms of the decreasing and increasing of the input and the output token balances of the user who call this method. And we have these checks that the balances should have increased and decreased. And based on that, we're able to verify that we are able to make these complex operations work in just one transaction, right? And a similar flow is here for deposit interactions as well. The only difference that you'll see is that the output token is basically the output address is basically the Curve LP address in this case, because with Curve, when you deposit liquidity, you get a LP token back. So this is the address of the LP token that we're using, and we'll be unwrapping the LP token at the end, right? So it's pretty much the same process as in swap. The only difference is the token address that we're using, right? And the other thing is, which is the last part of it is test withdraw, which is again just the withdrawal side of things, where again the difference is that the input token is the LP token, and the output token is is either USDC or USDT, depending again on the fuzz input that we get, right? So we can either, based on that, we have like the test logic in a way, handled in a way where it will adjust the address of the output token. Right, and again, the interaction process, again, it's the same. You have, an array of 3 items, and the input address in this case is the LP token, and the output address is, like I said, is based on the fuzz inputs, right? And again, we check balances at the end, that these balances should be correct, right? And now I'm just gonna run it on my local terminal just to show you guys that how the logs of the transaction look like. Yeah. Yeah. I'll just probably just increase this. Yeah. Yeah, so it's just compiling and it will run the 3 test scenarios that we just discussed. And it'll show a lot because with Foundry you just see the test logs, right? It's just taking time to compile. Oh, give me a sec, sorry. Yeah, it's just taking some time to compile, and then once we have it, we'll be able to see the test logs. Yeah, just some warnings, and yeah, it's just running the test. Okay. Let me check this once. Probably have the wrong. I'll probably debug this once. Yeah, I'll probably debug this, but yeah. Anyways, the idea is to do these operations basically atomically, in that sense that you can do multiple operations, multiple interactions, and compute that, combine them into one, and and yeah, if and we're looking for more devs to sort of like build on. To sort of build on shell, like create their own adapters which interact with these external DeFi protocols. And our team's going to be here at the venue throughout the week. So in case you guys have any queries or want to discuss any ideas, very happy to discuss that. And we'd love to, want more people sort of experimenting with the shell contracts. They have been audited recently, released a new version. And we released a new version out there, the V3. And yeah, happy to chat around the contract architecture or any use cases that you're excited about in terms of building for the hackathon or in general. And this is our website. You can scan the code and learn more about it. And yeah, happy to answer any questions. Yep. Thanks. Does anyone have any questions? Thanks, guys.
Can you hear me? Okay. Thanks for inviting. Today I'm going to actually demonstrate a way to build Web2 applications, especially browser Web2 applications using CK virtual machine. And in particular, CK WebAssembly virtual machine that are built by the Definite Lab. And I was the founder of Definite Lab and the main contributor of this CK virtual machine. The agenda of this talk is split into 5 sections. At first place, I'm going to introduce a little bit about the WebAssembly bytecode. And then I will going to introduce the way to integration of CK WebAssembly emulator with browser applications. And then I will demonstrate how to develop a tiny, fully on-chain game on top of our virtual machine. And by demoing that, I'm going to introduce a standard programming model. It's called MVC, so that which perfectly fits our architecture. And then I will introduce our proving service, which is WebAssembly CK Virtual Machine Cloud. Okay, let's start. So, what is WebAssembly? WebAssembly is an instruction set architecture, so which is a binary encoding format that can be run by WebAssembly virtual machines on any hardware or software that supports this ISA. And especially this can be run in browsers. So which leads to our current discussion about how to actually port in WebAssembly applications in browsers into a CK WebAssembly virtual machine application. And so far, the WebAssembly bytecode is now supported as backends for most of the traditional languages. For example, JavaScript, C, C++, Rust, Swift can all be compiled into WebAssembly and it runs in the browser. Okay, so what we can do using WebAssembly in the browser, I mark all these orange color titles to be the applications that we are interested at. So we can build peer-to-peer applications, especially games, in a browser, and building music applications, streaming and caching applications in browser. Also scientific visualization and simulations in browser, and definitely fat clients for enterprise applications, especially database and database services in browser. And outside browser, we can use WebAssembly to distribute game services and build hybrid native applications on mobile devices and symmetric computation across multiple nodes. For example, Substrate utilize WebAssembly virtual machine to build their chain facilities. And how WebAssembly can be used in browser applications is that modern web browser applications and browsers these days can natively support running WebAssembly. That means we can use WebAssembly and embed WebAssembly in the browser as the main logic, and the UI and the UI UX remains written in JavaScript and HTML. So today, my main target is trying to demonstrate how to separate the logic of a browser application so that we can replace the logic, the main logic with WebAssembly, and then run WebAssembly in our CK WebAssembly virtual machine to generate trustless computations in the browser. Okay. Before we have introduced about what is WebAssembly bytecode and how we use that in the browser, now I'm going to introduce a little bit about CK WebAssembly. The CK WebAssembly is a CK virtual machine that supports WebAssembly bytecode. It has 3 main functionalities. First, it actually runs the WebAssembly bytecode and generates proof and generates results. And the second, that it generates the same result as other WebAssembly virtual machines, just like the browser did. So that means it generates the same result as the browser did for WebAssembly. And the third thing, that the CK WebAssembly virtual machine not only generates the result, but also provides the CK proof, which actually proves the correctness of the result of the execution of a WASM binary. Okay, and this is a brief of the architecture. So to integrate a CK virtual machine in a browser application is a little bit subtle, and I'm going to review the classical application architecture of how we build a Web 2.5 application in the old school way. So first we can see that the applications run separately outside the blockchain. If you actually run the application in the browser. And the application triggers on-chain data modification. And then this on-chain data modification gets signed and posted to the blockchain. This is a very efficient but less secure way to do applications because all the computation in the application side is not trustless, right? You depend on some centralized servers to actually sign the transactions and sign the logic so that it conveys the on-chain contract that a certain kind of logic has been carried off-chain. Okay, how to make this architecture a little bit more secure? The idea is that we would like to put everything on-chain. For the first try, would like to put everything on-chain. So after that, the architecture will look like this, which we embedded all the logic on-chain. That means if you would like to do a complicated UI UX application, you have to sign all the transactions every time you modify and play a certain application. For example, a game, you move right, move left, every movement you have to sign that, and then you upload your transaction to on-chain and update the on-chain state. The problem of this fully on-chain application structure is that it's not very efficient, and it actually involves lots of signature, which actually triggers lots of gas cost. So, which is definitely not fit for certain applications like gaming. So our application, our solution is that we still would like to have an effect of trustless for the on-chain application, but we're using the CK technology, which actually transforms the logic part, not on the blockchain, but in a CK virtual machine. So that in a CK virtual machine, every time we interact with the application, we emulate and prove the result in the CK WebAssembly virtual machine, and then push the state diff with proof to the blockchain and do the settlement afterwards. Okay, so regarding this architecture, I'm going to demonstrate how to do that, because at first glance, people might think this is too complicated, but actually it is pretty simple if you're using the correct tooling. Okay, I'm going to demonstrate a small card game which runs in our WebAssembly application sandbox. And here, we are going to load a small game, which is a very dumb, trivial card game. On the left-hand side, I'm the player, and on the right-hand side is the monster that I'm going to defeat. So just imagine that in our Web 2.5 world, this logic is run off-chain, right? Untrustless, run off-chain, and every time we play a card, like we strike, it actually decreases the HP of the monster, and it's calculated off-chain. But what's the difference now is that we not actually only run this in a browser environment, we also run this in a CK WebAssembly environment, which is the sandbox of this demo. So that if we perform lots of transactions, you see that we're not going to sign every transaction all the time, but every time we click anything, play and click anything, this is run, sorry, I get killed. But anyway, this actually finishes the game. So it might involve lots of transactions, but we're not going to sign all the transactions during the play. But what we do is that we have a sequence of user inputs. And because this game is can be run in a CK WebAssembly virtual machine, we can generate a proof for the game. For example, we can submit and generate a proof. So if I click confirm, it signed all transaction for me and then push the execution trace to a proof generator, which actually generates the proof of the gameplay to a cloud proof generating service. Okay. So it's actually loading task. So this is the new task that we have just submitted. And this cloud CK WebAssembly proving service will generate a proving for our gameplay. And after we get that proved, it might take a few seconds, maybe 10 seconds or 30 seconds. No, to maybe take longer. It depends on the trace and circuit size regarding how much time it will consume. So once we have done a proof, it has been done now. Once we have generated a proof, we see that all the inputs actually represent the gameplay that the users have performed on this game. And we generate a CK snark proof, which can be used to convince the on-chain contracts that this kind of game is executed in a CK WebAssembly sandbox. And the execution trace and the result and the reward is somehow calculated securely and trustlessly. So we can use this proof to verify on-chain. Okay, select the chain. Let's see this one. And we can, so sorry, maybe I have to connect to my wallet. Okay. So we can actually verify this proof on-chain and do some kind of settlement. Confirm, do the settlement. And you can somehow automate in your settlement contract to decide what kind of reward you are going to give a player after he have finished a long sequence of gameplay. For example, you can design a game, which is a SLG, and after 1,000 steps of gameplay, you can give him some rewards. And this contract demonstrates about how we can coding the callbacks once a proof has been accepted. For example, if someone would like to give a token transfer, if someone has finished a very good gameplay, he can write a verify function which actually verifies the proof at this place, and then call the side effect function. And based on the core data that the user has pushed to the blockchain, he can decide what rewards he could pay the player. So these side effect callback functions are the key to actually reward the user or give feedback to the user. And there are several good points of using this architecture. Firstly, you do not have to sign every movement of your gameplay. And the second thing that it's very smooth, and because it's running natively in the web, in the browser, that means you can coding a Web3 application just like you're coding a Web2 application. You can using JavaScript, Rust, C, C++, and then compile them to the WebAssembly and put your game straightly on a browser application, WordPress, in any kind of cloud service, and run the game, ask the user to play the game, generate a trace, and generate a proof. Because all the execution is performed in a CK virtual machine, there's no security issue, right? And there's a small subtle thing that at the beginning I asked you to log in your wallet and assign an address, which means every time you play a game, you log in with a local generated signature. And this signature will be verified every time you push the proof to the on-chain verifier, so that no one can actually fake the gameplay and get your rewards. Right. Okay. So this is a complete front-end demo about how to use the WebAssembly virtual machine and embed your application in the browser. But there's another part. It's about how you actually coding your application, right? The coding application is not just putting the sandbox and adding some code just straight in the browser HTML, right? You have to coding your game logic in a WebAssembly. That means you have to pick a language that can be compiled into WebAssembly bytecode. The alternatives will be the JavaScript, the TypeScript, the assembly script, definitely, and the C, C++, and the Rust. In this demo, we use the Rust as our development language. And let's see how the game is developed. By the way, when we actually developing this demo, we're using architecture called MVC, which somehow separates the view and the model. And what we are interested in is that we would like to run the model and the controller in the WebAssembly virtual machine, but not our view, right? But the view, because the view is a representation of the model itself. And it has no point to actually prove the view for the on-chain verifier. So we mainly focus on the model and the controller. Okay, here is how we coding the game. Let's first see the makefile, because the makefile sketch out the deployment of our gaming this time. We see the first line is the compiling command that actually compiles our full code into a WebAssembly package, right? So after we compile this, we see that in the package folder, we have our target files. It contains the main WebAssemblies and the type definition of our WebAssembly and the loading script that we can use to load the WebAssembly in the browser application. So we copy all these files into our React web application. And we copied it here. Okay, we copied it here. And after that, we coding the controller using a tool called React. It's pretty simple. You put some buttons and add some on-click event handlers for the controller, which gives you some kind of callback when you actually click this button. Click. Okay. So when you actually click this button, I think it picks a card, right? Here. You click the button, you pick a card. So what does the pick card mean? Because this is a controller, right? It has to call and interact with our WebAssembly. So that means this controller will eventually call into our WebAssembly code. And this pick card looks like this. Pick card, right? And see this init as any, and this is the WebAssembly that we have loaded. This is the WebAssembly. So the pick card means you somehow get the handle of the WebAssembly you have just loaded, and you play a card, right? You play a card. It's pretty easy, right? So now this demonstrates that how we can load and interact with the WebAssembly image in our browser application. Okay, now the most interesting part is how we coding the WebAssembly. So how we lay out and coding the WebAssembly so that it becomes an interesting application. For the applications that I'm demo at the moment, is a simple application, right? It has a global state and some activities that I can perform to actually change the global state. And if actually I win, I can somehow generate a proof and tell the on-chain contracts that okay, I have win this game, please give me the reward. Okay. So let's see how the game is coded. Because all this WebAssembly has to be run in a CK virtual machine, we have to specify entry point of the image. And this entry point looks like this. The entry point calls the CK main, right? It's just relevant to a main function, but we call it CK main because the CK virtual machine will run this and generate the proof of this entry function. And besides the core command handler, we have some signature handling stuff, which asks the user to actually sign the contract once they have finished a bunch of play. The core feature is that we perform the command in the loop, right? So in the loop, we somehow collect the command from the user. That means every time we click a button, the handler will somehow transform the command and transfer the command into the WebAssembly handler. And the handler will actually catch this command and perform the state transformation internally in our Rust code. So that means, just remember, in the Rust code, you have a large global state. And the handler actually performs all sorts of commands and change the global state. And every time we somehow change the global state, you still have to render the user, right, based on the global state that you have changed. So that gives another issue that we have to face, which is actually get the information back from our WebAssembly code. So somehow get a global state. And this is pretty straightforward because we can transfer the global state as JSON to the UI UX. You see that, okay, here is the global state. We have lots of features like how many cards it has, and if I actually play one card, I get another global state. So that the procedure will be I play a card, which actually triggers a command, and then which invokes the WebAssembly application. The WebAssembly application somehow handles the command, performs the command, and change the global state. And now the UI UX somehow receive the global state back, and then render the application again, right? After several play, you reach a global state which is stable, and you can say, okay, I have finished my gameplay. At that stage, there's no signature happening, right? But if you're happy with the gameplay, you can somehow generate a proof, right? Just like what I have just done before, I think 10 minutes ago. And at this place, you somehow sign the gameplay and generate a proof from our WebAssembly cloud. Okay. See, there's a new proof generating at the moment. Okay, that's the whole story of the game development. And after that, I'm going to introduce slightly a little bit about our CK Wasm cloud. Because we have seen that once we have finished the gameplay, we need some kind of proving service, somehow generating proof for the CK virtual machine. And you can run a CK virtual machine locally, just download our GitHub repo and set up a local server. It's fine. But for the cost effectiveness, you would like to integrate with the on-chain stable service so that you can submit your image, a game image, to the cloud. And every time you would like to generate a proof, you ask the cloud to generate the proof for you. And this is the WebAssembly image hosting and proving service. And it's pretty simple to actually uploading an image to the cloud service, which is just a one-line code. We call it publish. It's pretty simple. You download our SDK and connecting with our cloud CK Wasm service and provide the WebAssembly you have just coded and would like to play in your browser. Specify your private. Is this recorded? Okay. And then let's run that. So because I have already run this script before, so it will give me an error that this WebAssembly image has been uploaded already. But if you have not actually uploaded this image, it will give you a WebAssembly MD5 code. And you can use this code and inject this code into your configure so that the gameplay can somehow know which image you are regarding to when you would like to generate a proof. And this is done in the configure file. So just copy that MD5 to this configure file, and you will get this small on-chain, fully trustless, off-chain game for Web3, which means theoretically you can turn every web applications into Web3 trustlessly using the WebAssembly CK virtual machine. Thanks.
Oh yeah. Can you hear me, guys? All right, let's kick it off. So hi, everyone. My name is Marcin. I'm co-founder of Redstone Oracles. And most likely, you've seen on the agenda my other co-founder, Jacob, who unfortunately yesterday couldn't board the plane. So I will be running the presentation. And also there is a slight change in the topic, so it's not going to be super technical because I'm not like a coder myself. But it will be mainly about rollup as a service and oracles. And I would try to bring down a bit more the concept of like how oracles differentiate from each other and why would you have another oracle probably than Chainlink that the majority of the market is very much familiar with. So throughout the presentation, I will try to ask some questions, and my idea was to give out some Redstone merch for people to who would answer that. But I think it will be probably a bit difficult with the space over here. So just after the presentation, if you'd like to get some Redstone merch, like catch me up, and I'm happy to distribute some socks and other goodies. So no further ado. Oh, I'm also co-founder of ETHDenver24-Trident, which is a conference and hackathon in Warsaw, Poland, which I recommend joining this year. A bit about Redstone before we kick it off. So we've started late 2020 and came with the final version of the product in early 2023. So January 2023 was when the first full production application started using Redstone. It was Delta Prime. And since the inception, we managed to close $8 million in funding. The seed round was led by Lemnis Cap and had some good names like Coinbase Ventures, Blockchain Capital, Maven 11, also joining and believing in our vision in disturbing the Oracle space. We also got backing from one of the most prominent angels in the space, including Stani Kuleho, founder of Aave, Sandeep from Polygon, Alex Gluchowski, founder of ZK Sync, or Emin, founder of Avalanche. One thing that you're going to notice, many of these founders have their own like ecosystems chains, and they understand the necessity of diversity with oracles, especially not having like just one provider to be dependent on. We are pretty recognizable right now in the space with our reports. We've published 5 so far. So every quarter we do a deep dive into a sector that relies heavily on oracles and try to bring down the main players, the dynamics of the sector, and what kind of a role oracles play in there. So we've done stablecoins, real-world assets, liquid staking tokens, which was by far the most read one. It had over 500,000 views so far, liquid restaking tokens, and crypto yield and earn products. So if you want to check them out, you can go to our website or Twitter. They're fairly available, and it's, I would say, a really comprehensive overview of the particular part of the DeFi game that we described in there. And we are a team of 15 cool people, actually. I mean, like, we care a lot about the culture fit and also being professional and also easygoing when you join Redstone. So right now we are 15, always with Redstone merch like vests, socks, and other stuff. Yeah, so this is a bit about us. Before I jump into like the different types of oracles, maybe first why you need an oracle in general in DeFi, in blockchain, in crypto, right? So oracles deliver data to dApps for smart contracts execution. It should be as broad and as simple as that. But actually, if you are proficient within the space, you will quickly realize that currently it's mainly market data, so volume, interest rate, market cap, and so on, because right now, crypto is mainly around DeFi, and these are the statistics, data that DeFi protocols need to execute properly. And then if you're within the Oracle space, you're going to quickly realize that you have to narrow it down even more, because actually right now, as it is of today, February 2024, over 95% of the data delivered by oracles are price feeds of assets, and mainly crypto, not even like assets from real world. I mean, more and more from real world, but majority of that is what's the price of Bitcoin, what's the price of Ethereum, what's the price of USDT, and so on and so forth for DeFi protocols. So you're going to quickly realize that oracles is like a super broad concept, like, okay, bringing data on chain, cool, for execution. But then the implementation is so hard and also so expensive to create a robust, decentralized, and resilient oracle that currently the product market fit is mainly about price information, about assets, mainly crypto. And I wanted to ask a question, what is the most utilized price feed right now in the whole DeFi? But can someone try to answer if you know? All right, I think it's pretty difficult to hear, but it's ETHUSD. So as it is of today, 90% of the queries when it comes to price feeds is on ETHUSD. And the major reason for that is because Ethereum is the biggest chain, right? And then many protocols, even if they require another price feed, they denominate all of that stuff into ETH. So in many places in their system, the denomination between ETH and USD is crucial, right? And right now we see the biggest increase actually in derivatives of ETH. So liquid staking tokens and liquid restaking tokens, because they are bearing yield and they are used many times across various lending, CDP options, and so on protocols. So what are the use cases for oracles when I talk about DeFi? So actually oracles will be at one point used widely in Web3 ecosystem. That's probably given, but until now it's been mainly focused on DeFi. So price feeds at DeFi, these are oracles as of 2024, at least early. You use them in lending markets such as Aave or Venus on many chains. CDP stablecoins, the most recognized one are MakerDAO, Liquidity, but there are also like rising stars like Prisma. Leverage protocols, so Gearbox, Delta Prime, Kian, and more. Derivative protocols, commonly also referred to as perp protocols or perps. So GMX, especially right now with their V2, or synthetic perps, or Vertex, or other perpetual platforms, are using oracles for pricing the assets that they are allowing to trade. Yield and earn protocols. So right now I would say the major players are Sommelier, Enzyme, DeFi Saver, InstaDApp, and so on. So these are the protocols that also rely heavily on the price feeds from oracles. And algorithmic stablecoins like Mento or Frax. Can you come up with 2 DeFi protocol types that doesn't need Oracle? Because I'm talking about many that do need. So if you turn the tables, it turns out that DEXs usually do not utilize oracles, so like Uniswap, SushiSwap, and so on. The main reason is because people trade on these DEXs, and actually it's the reverse. So oracles many times rely on DEXs as price feed sources. So they catch what's the price of the trades and then aggregate it from many sources and deliver to the protocol. If you can call a DeFi protocol a bridge, then they also do not rely on oracles. And there's probably some others. But if you extract like 3 or 4 categories, then all of the rest of the DeFi do need oracles. Sometimes there are new architectures, like with Anja, that try to create lending platforms or DeFi oracle-less. Because oracles, if you can create a protocol without oracle, do so. I mean, like oracles are just another piece of the whole puzzle that can go down or can be manipulated or can be something wrong with it. But majority of the times, if you want to keep the app fairly with a good UX and also performant and competitive on the market, you do need to rely on oracles. So why do oracles matter for RAS? So RAS stands for Rollup as a Service, and it's a service where a party just requires a rollup for their specific use case. May it be DeFi, gaming, or something else. And many times when you create a rollup, you're like, okay, let's go to one of the providers like Conduit, Outlayer, Gelato, Caldera, and you create your rollup, and you're like, hey, I have my own chain, it's cool. But it turns out you need also infrastructure on top of it, and oracles usually are a very essential part of this infrastructure. So if you want to have DeFi on your rollup, you need an oracle. And you can probably just call Chainlink, hey guys, like, can you please deploy on my chain? Like, I just have it deployed like in 2 weeks. Can you come over there? Then you might get an answer, of course. Like, I will put you in the pipeline probably in a couple of months or maybe even longer. Don't get me wrong. Like, I appreciate Chainlink a lot, actually, but for them and creating super robust system that almost never got truly has never malfunctioned. We wouldn't have DeFi as we know it today. So we do need Chainlink, and it's like a super important part of the whole ecosystem. But there are not that many sectors in DeFi that are as monopolized as oracles, and it's like a critical part of the DeFi stack, so we need more diversity in there. So I would be asking like how many chains does Chainlink support? And it's right now roughly 13, 14 chains. If you take out the legacy chains, because there are some, it's more like even 12. And then you realize that in current world, we have probably like 30, let's call them viable chains, 50 maybe promising chains, and then the whole sector of rollup as a service, so new chains that are popping out every other week or month. So you see that not the whole spectrum is covered by the main Oracle provider. And actually, the other question would be, do you know any other DeFi vertical that has been that much monopolized as oracles? So some people claim DEXs with Uniswap, but actually I would say right now with so many chains and so many various flavors of creating a DEX, and also like if you add perp DEXs, it's not that monopolized anymore. Like there is innovation. With wallets, of course, like MetaMask is the main one, the main used one, but the competition is like very fierce over there. And so my claim would be there's probably no other like DeFi vertical as heavily dependent on one provider as oracles, which in our stance shouldn't be the case, probably. So then the question, why Chainlink is not on all the chains? Like what's stopping them from being present everywhere and joining the rollup as a service very quickly and efficiently? So the key bottleneck when it comes to oracles in general, as we know nowadays, is that on-chain data storage cost is very high, and monitoring infrastructure is also like pretty expensive. So the key consideration that each oracle is taking into account is the update condition and the cost of one update. So how many times I need to update something on chain, and what's the price of each update? You can multiply, and then you can get a cost over, for example, a month. So there are two main implementations visible on the market right now, and Chainlink also has both of them. We also have both of them, and other oracles also tend to offer either or both of them, which is push oracles versus pull oracles. And for anyone over here who really would like to be within DeFi and understand the space, I would say you should know this concept, because it's going to be repetitive over and over for the next month. So what's the difference between the push oracle and the pull oracle? And I will try to break it down in a second. So the main idea of the push oracle is like the infrastructure that Chainlink brought to us 2019, 2020 and popularized, is when you aggregate data from various sources, say it is decentralized DEXs, centralized exchanges, price aggregators like CoinGecko, CoinMarketCap. You aggregate that in a layer. For Chainlink, it's Dawn, decentralized Oracle network. And then you shoot that data on-chain into the storage with intervals. And these intervals are dependent on a time interval or a specified price deviation. What it means is, for example, when you have ETHUSD price feed and you want to update it on-chain, you are going to update it, for example, every 24 hours, so that there is like a heartbeat. Or the second condition is the deviation. So when it deviates from the previous update for at least, for example, 0.5% or 1%. So you're never going to have real-time data on-chain because it's just too expensive. So you're accepting that there is always going to be a specific acceptable difference. So in that case, if it's, for example, 1%, so you can have a difference, an arbitrage of up to 0.99 of percentage point for ETHUSD on-chain. And when you add to that the volume that such a feed is protecting, then the arbitrage is pretty big. In pull oracles, the main idea is to update data on demand. So when there's a transaction of a user that requires a data feed from an oracle, then you deliver that data on-chain. So only when it's truly necessary and the transaction cannot go through without the oracle data, only then you're delivering that. And that's the main concept and idea of a pull oracle. So usually the user interaction is the update or trigger condition, not like an interval or heartbeat, right? And now why is it important? If you create an oracle that is just dependent on the heartbeat, then it's fairly easy to calculate how many updates you're going to have for a month. And then the only variable you have is the cost of one update, because we know that the gas on various chains like deviates all the time. Then if you add the deviation threshold, then you cannot even predict how many updates you're going to have throughout the month. So you have no idea what your cost of running an Oracle is going to be. Is it going to be $200? Is it going to be $500? Or is it going to be like $30,000? With the gas spikes on Ethereum, sometimes it can be even like crazy number, like in millions. Like believe me, we did our calculations, and operating like Chainlink oracles on Ethereum in the moments of a heavy gas spikes can cost even millions of dollars weekly. That's crazy. That's insane. But this is like the cost that you have to bear so that the price feeds are updated on chain. In Pool Oracle, you can also you also cannot predict how many updates you are going to have, because these are the users that interact with the dApp that are going to trigger the updates. So if it's like, for example, night, or okay, there's never night all over the world, but let's say it's night in the heavy traffic geographical regions, or the market is just pretty flat and there is no much movement, you're going to have just a few updates. But if there's like a heavy movement market, like, I don't know, Uni token goes up like 30% within like hour or something else, people usually trade. They try to catch like an opportunity, and then you're going to have many transactions, so many updates. But here is one very important caveat, is who covers the gas. Because it doesn't have to be the Oracle that covers the gas. In the push Oracle, usually it's either the Oracle provider that covers the gas of each update, and then either subsidize that, and that's what Chainlink has been doing for a very long time. Like, they've been subsidizing these updates, so that is like more like a public good. Or it can be a protocol, either the one that consumes the data, or the one that the price feed of an asset is updated for. So for example, in, let's say, ideal world, probably the gas coverage for updates of ETHUSD should be covered by Ethereum Foundation, because Ethereum is like the coin that they are kind of like keeping, so they probably should be the sponsor. But you're not going to charge Ethereum Foundation. They might give you a grant. With new protocols, right now we see that pattern, that it's in their interest, like in the interest of the coin issuer, to have the Oracle running, because that creates a market on DeFi for their price feed. They can go to Aave or other protocol, Compounds, Prisma, and so on, and try to lobby to add their price, like an asset as a collateral in the protocol. So it's in their interest to cover that. Whereas in the on-demand and pool model, that's super interesting, because usually you create a system where the user is actually covering the gas cost. Right now, the majority of the cases, the user is paying additional gas on his or her transaction in order to update the price on chain. So the logic is more like, hey, I want to interact with this protocol, so I have to accept the gas that it costs to interact in general, plus the gas cost of the Oracle update, because without an Oracle, this protocol wouldn't work. And then you verify whether the users are actually willing to pay the gas. And the whole game is about how much gas it adds. If your regular transaction costs $15 and you're going to add a gas cost of like 20 cents, probably majority of the people are going to accept that. But if the cost of your transaction is on, I don't know, BNB chain or Arbitrum or something cheap, 20 cents, and then you add additional 20 cents for the gas update, for the Oracle update, which is like 100% increase in the gas cost you have to pay, then it might be a problem. Is it like justifiable or not? So many oracles, including us, try to optimize the gas cost of adding these price feeds to transactions of users. There's also like a new thing that Oracle started like experimenting with end of 2023 and beginning of 24, is to create a kind of like an accounting system of how many updates have been done by users of that protocol on chain, gather it throughout the month, and then the protocol pays a reimbursement, for example, to the Oracle for all the updates that have been triggered by the user. So there's always the question, like, who is going to pay this gas? Because this is the most unpredictable cost, and it can deviate truly a lot. Believe me, it's like between $50 and $50 million, like in some time frame. So it's a very pain in the ass. When it comes to going cross-chain, Push Oracle is non-scalable. The reason for that is because you have a service that is delivering data on-chain. Imagine it's ETHUSD, and it delivers on-chain with specific like conditions, right? But then if you have another chain, and you want to have the same data on the other chain, you cannot just, you could potentially like query the other chain, but there would be like a latency of querying the other chain, and actually it's going to be expensive as well. So for the same price feed, ETHUSD, you have to shoot that to one chain, to the other, and every other that you want to deploy to. So here you can quickly realize that it's not scalable because the same price feed has to be updated on many chains. And there is like bigger and bigger complexity because the chains are not identical. Many times you hear it's EVM, it's the same. Actually, it's not, because you have different RPC provider, you have different like caveats in the code, like how the guys are actually made it EVM. Sometimes you have problems with signatures and yada, yada, yada. So people try to make something EVM, but usually there are some trade-offs if it's like not true like native EVM. And then you have non-EVM chains, which makes it even more complex because with each chain, you have some other like configurations within the ecosystem to make the updates on the given ecosystem. With the pool model, many times you try to create a system that, because they use, like, for the Oracle, it doesn't matter, it shouldn't matter, like, to which chain the user is sending the transaction, because you try to trigger the Oracle update with the user transaction. So with Redstone, what we created a flow that works out of the box on all EVM chains. The reason for that is we found that on all EVMs, you have call data in each user transaction, and you can pass some message in call data. I'm going to talk about that in a second. And that's what we use. Some other oracles use, for example, bridges or other passing services to deliver data onto many various blockchains. So by principle, it's just more scalable with the pool and on-demand model. And when it comes to number of feeds, that's actually pretty connected with the previous point. Because, okay, you can have like just one price feed, ETHUSD, but if you want to create truly DeFi, you probably would like to have the number of feeds, like, I don't know, at least 10, or maybe 20, or maybe 100. And then if you think about push oracles, where you have to push oracles on chain, each single price feed is going to have its own heartbeat and deviation threshold, because it's not like if deviated like 0.5%, it doesn't mean that Bitcoin deviated 0.5%. So you have to create one monitoring for these deviations for each single asset and update conditions for each single asset. So then you get a matrix of many to many with many chains, like how you're going to update them. And then you also learn that the chains don't necessarily want the same price feeds. So everyone wants ETHUSD, that's given. But when it comes, for example, for Aave token or Uni token, it doesn't mean that every single chain is going to need the same price feed. So you have even more complexity in there. When it comes to pool oracle, usually you keep these price feeds off-chain in any sort of a construct or another blockchain from which you query. So it's way, way easier to make it scalable in the sense of the number of price feeds you support. So sometimes you can even do like 100 or 1,000 price feeds without that much additional fixed cost when it comes to the destination chain. So how does the standard push oracle model flow looks like? You have data sources, as I mentioned, decentralized exchanges, centralized exchanges, or price aggregators. You have node operators or data providers, people call them differently, like T-Mobile or Flow Traders, who is a market maker, or Kaiko, that aggregate that data. And then you have a smart contract on the target chain towards which the data is pushed with these conditions I mentioned before. So say it's Ethereum, Arbitrum, Avalanche, Solana, and so on and so forth. And then when you have a dApp that is deployed on that chain, the smart contract of the dApp can query the smart contract of the Oracle and get the freshest, let's say, price feed. So this is very elegant and very simple. And this created the DeFi as we mostly know right now. But if you want to like scale it, it probably is not going to make it affordable at large. So it's not scalable across chains and number of assets. How we perceive that is a bit like early time emails, or like we still use emails, right? Like everyone uses that, and they haven't changed that much since the inception. So like it's a very important construct, but we also created many new concept of messaging between people, like Telegram, WhatsApp, and so on and so forth. So our view is push model is going to stay over there and it's going to play a super important role, but we also have to innovate to make these like boundaries not relevant for specific types of applications, because in our view, updates of 24 hours and 0.5% deviation is not going to bring us to the new financial system as we all want to build here in DeFi. So the pool and on-demand Oracle model looks a bit differently. On the left, for you, actually looks the same. So we have data sources and data provider nodes. So that part doesn't change. But what changes is that these data providers, after aggregation or price discovery, they do not shoot data on-chain directly, but there is like a sort of a middle layer that is way, way cheaper than pushing data on-chain because it doesn't usually contain gas, or if it does contain gas, the gas is marginal. So they sign these data packages and send it to a middle layer. In Redstone case, we call it data distribution layer, or for simplicity, it's like an off-chain cache. So a set of gossiping nodes that keep signed data packages for a short period of time so that it's available for anyone to pick and is redundant. Like you cannot DDoS that. For PIF, for example, another Oracle provider, it's PIFnet, which is a Solana fork, which they govern. They have 100% of supply of the tokens, so they can fairly easily look like what's the gas price, and they pay it actually in the native token, so it doesn't matter for them. And other oracles, they have their own like middle layer as long as they provide the pool model. And then when there is a user transaction, so the trigger, then they deliver the data feed onto the target layer 1 or layer 2. So for example, for PIFnet, they rely on a bridge, which is called Wormhole, one of the biggest players on the market. It can be actually picked up by a liquidator. So not only oracles deliver price on-chain, like if a liquidator is allowed to deliver a price feed in order to close a position on Aave or other market, they can also like deliver that. So a liquidator can be like a party that brings data from this middle layer to the on-chain environment. Or in our case, in Redstone, we were like, okay, users send transaction on-chain anyway, so probably the most efficient, gas-efficient, and also elegant way to do that whole flow is to piggyback user transaction that goes anyway, so you don't have to trigger anything else. And we found a way to do so in this called data. If you want to check out how Redstone Flow actually works on like, I don't know, 50 chains, like EVM chains, you can just go to showroom.redstone.finance. You can quickly connect to one of the chains and then see how the sampled data is actually delivered in this cold data field. So why I'm repeating this cold data, cold data, cold data, because many people don't know about this construct, and it's super important in my view. So cold data is read-only byte addressable space. For example, in Ethereum, which is like a state machine, you have state 1 and then state A and then state B, and between you have a transaction. In the transaction, you have, of course, like information from who to who and the value, but you also have data, this called data, where usually you pass arguments for the function. So here is, for example, Charlie from the second field, and from the third field, and 2 from the second field. So these are like arguments. But you can add there any arbitrary data as long as, let's say, it's gas efficient. So our founder, who used to be smart contract auditor with Open Zeppelin and has been in the Ethereum space since 2015, created a very optimized EVM connector library that we utilize in order to attach the signed data packages from this middle layer to the transaction of a user, so that goes to the destination chain. This is actually from Ethereum white paper. All right, so when you're creating your new chain with Rollup as a service, or not necessarily, you're just launching a new L2. We've seen many recently, like Blast, Mode, Fractal. Right now, there are a lot of L2s on top of Bitcoin. So all of these, if they want to play with DeFi, they need oracles. So they usually have to take into consideration like which oracle they would like to have on their ecosystem. And the consideration they have, again, is like the push, you have the interval and deviation, pull, it's user interaction. That's actually the same table as before. So from the lens of a L2, like an ecosystem or Rollup as a service provider, you have to take into consideration the waiting time for the deployment. So how long do I have to wait for the oracle? The cost of deploying of the oracle, so what actually I'm going to pay, and what's the maintenance, and types of applications that I want to have on my ecosystem. Because some applications work only with the push model, some applications work only with the pull model, and some applications actually can work with either. And in my opinion, like, if you can create right now from the scratch a protocol that is going to be able to fetch data from pull or push oracle, depending, for example, which one is the freshest or the most accurate, this is, in my opinion, at least the near future. Synthetics is working on something like that. There's a protocol that is launching soon called Curvenance that created such a system. So it's like a new way of querying the data from oracles that is, let's say, the most fresh and the most robust. So waiting time with push oracle is always way longer than pull oracles because you have to create this whole setup for shooting data on chain. the cost is also higher. So that's the reason you have to innovate. And right now, I have to be frank, majority of applications are just used to push oracles. And even though in their flow they could include pull oracles, they prefer not to because they audited the code, did something else, and they just wait until the push oracle is available. So this is the state as it is today. But in my opinion, as we go forward, with all the limitations I meant before, the developers will be innovating to incorporate more and more pull or on-demand oracles into their system. Actually, there is one more consideration when you're creating a new chain. Hey, probably you're going to have your own token, right? So if you're creating modes, there's probably going to be mode token, blast token. We see Arbitrum has ARP, Optimus has OP. So there is probably like a token with the chain that you're creating. And for you, it's going to be essential to have a price feed for that particular token on your network. So with push oracles, it's tricky because if you are going to configure, let's say, ARP price feed to USD, most likely other chains are going to use that as well because the market cap is really high. But if you're just bootstrapping the network, there is no much sense for other chains to need that price feed. So it's going to be super custom just for your particular ecosystem. And many times in push oracles, the cost is just you cannot justify that. So a couple of case studies when it comes to rollup as a service providers. There is a rollup as a service provider called Caldera that has many types of stacks like OP stack, Polygon stack, Arbitrum stack. And Manta Pacific is one of the chains that they helped bootstrap. They started and right now is running on OP stack with Celestia as DA layer, but they will be switching over to Polygon ZK EVM. And it's a pretty good success story right now. Manta itself has, I don't know, probably like $800 million in TVL, and the ecosystem is still growing. You can also give life to the old chains that everyone thought will not gonna make it. So Lisk, if there are some crypto Gs you probably remember, like Lisk from back in the days in older times, like very smart team. I got to know their team personally, but in the recent months they probably haven't been so much active. But right now they partnered up with Gelato, which is another rollup as a service provider, and on top of OP stack, they're going to be transforming from a layer 1 into an L2 on top of rollup as a service provider. And actually, they are going to need oracles. Celo is transferring also from layer 1 to layer 2 without a provider, at least for now, as long as I know. But the forum of Celo is super interesting. If you've never been on a forum of Celo, I highly recommend you to check it out, because right now what's happening is Celo announced it's going to transfer into L2, but they haven't done any like final confirmation, like which L2 they are going to, like, or which stack they are going to choose. So right now, all the stack L2s, like Arbitrum stack, OP stack, ZK stack, ZK EVM stack, and so on, are creating a post on their forum, on Celo forum, and trying to convince them to use that particular technology. So if you were ever wondering, hey, what's the difference actually between Arbitrum stack and OP stack and so on, I highly recommend going over there, because these guys are flexing their muscles just in order to get Celo, because it's a pretty big ecosystem already. Canto is another type of a blockchain that has been or still is L1 and wants to transfer into L2. So you see, like, there's a pattern of older L1s that realize that probably it's just more economically viable to go into becoming an L2. Maybe one day we are going to see EOS. I don't know whether any of you remember the EOS ICO and knows this ecosystem, but the guys still have a lot of cash, so maybe we are going to see like a revival of that ecosystem in the form of a rollup as a service, or another player, Parallel, that also is going to launch, or I think maybe already launched, with Arbitrum stack, utilizing Conduit, as far as I remember, as a provider. So I'm going to go into wrap up, and one thing that I still want to leave with you is like a simplified framework, or maybe a couple of questions you should ask yourself when you are comparing oracles and you're trying to pick the one. So number one is customizability. Can I decide on which data provider to trust? So for example, with Chainlink, you're accepting the setup as it is. Chainlink is the one to decide like all the customizability aspects. But with, for example, Redstone, I believe PIF and other providers, you have more, let's say, gears to tweak in order to make it work for your particular chain or dApp. So you can, for example, say, hey, I don't like this data provider, so can you please disregard it? And then you just, in Redstone case, disregard the signature of this data provider, and then you accept it from all the others. So you have like the power to do the choice. Centralization, so can the Oracle switch off the infrastructure? And here it's, like, in my opinion, there is no perfectly decentralized Oracle, and in any time soon we are not going to see one because it's super hard to create something that is fully decentralized when it comes to such an infrastructure architecture. When it comes to Chainlink, to the best of my knowledge, there is like a multisig, I think like 5 out of 10 or something like this, that is governing all the contracts. In Redstone, we are also like slowly progressing in the decentralization, but it's, in my view, especially in Oracles, there is no like centralized and decentralized. There is a spectrum, and you have to like look like at what part of the spectrum a specific provider is, and if there is like a path to keep decentralizing the system. Redundancy, so what has to fail for the Oracle to go down? So what are the critical factors for the Oracle to keep operating properly? And evaluate what is the probability of this particular part to go down. So for example, if you rely on a bridge in a pool model, if that bridge goes down, actually your Oracle is not working unless you have like a backup system. Maybe there is, maybe there is not. So it's really important to check that out. Layer 1, Layer 2s, and Rollup as a Service compatibility. So is it designed to be cross-chain by design? Number and types of data feeds available, and how easy it is to add a new one. So we see right now also like some Oracles being super performant and optimized for specific price feeds. So for example, they offer only 3 price feeds, but let's say with very high speed or high performance, but they are limited to add new ones. On the other side, you might have less performant price feeds, but being able to add like new tokens as they go. On-chain versus off-chain price sources. Oh, so this is super interesting, especially important in the beginning of 2024. So can the Oracle, for example, provide a price feed for a token that is mainly traded on-chain, on DEXs? Because there is a suite of tokens right now that are not traded on centralized exchanges, are traded on DEXs, and actually can make as a perfect collateral for many of lending protocols. Because lending protocol, if the health factor of a position goes beyond a certain threshold, usually tries to sell the asset on decentralized exchanges. So the liquidity of these exchanges actually matter the most for them. So liquid staking tokens is an example. So wrap staked ETH, RE from Rocket Pool, SWE from Swell, OSE from Stakewise, ETHX from Stader, and many, many more. And in the beginning of 2024, we've seen the biggest boom for liquid restaking tokens. So the ones that when you lock your ETH, you get a liquid restaking token, and the ETH goes to protect EigenLayer and goes for restaking. So the biggest players are EtherFi, Renzo, KelpDAO, Puffer Finance. So these tokens work as perfect collateral as it is for today on the lending markets. So if an Oracle pulls data only from centralized exchanges, which is easier, in general, everything that is centralized and off-chain is easier, then this Oracle probably is not going to provide a price feed of an asset that is traded only on-chain. And the inherent nature of LSTs, LRTs, or also some other yield-bearing assets is that they are traded on DEXs. Uniswap, Curve, Balancer, you name it. Another one that is upcoming is Athena's USDE. So actually the most liquidity, especially in the beginning, is going to be on DEXs as well, most likely. So if you want to have earlier these, you have to verify on the Oracle. I haven't touched upon that one, but it's also like pretty crucial. What's the price aggregation methodology? So is it robust against, for example, wash trading? So wash trading is placing like 2 trades for the same asset that are opposite to each other, so that many times you try to omit, you try to create a loss so that you can omit taxes or some other aspects. And if you have a pool on DEXs with low liquidity and someone creates wash trade over there and the volume spikes, you can easily move that price. And actually this is something that we have seen, we have witnessed in December last year with Chainlink price feed Oracle for wrap staked ETH on Arbitrum. So in a balancer pool with low liquidity, there was someone who was trading $2 million of wrap staked ETH, and that moved the price because Chainlink is relying on VWAP, so volume-weighted aggregate price feed. And for on-chain, let's say, price discovery, it's not necessarily the best. It's better to track liquidity because it's harder to skew and more expensive to move across many places. Or is it price aggregation? Is it median? Or maybe is it something else? So it's also important to keep in mind. If there have been any historical mispricing and manipulations for an oracle, so has it failed in the past and how to understand whether they improved or not? Are there any guarantees? So if the protocol gets any damage because of an oracle, am I going to get any damage payout? Because there are many models, like through Redstone, we also work on a system that pays out the damage to the parties that are, for example, got a loss because of the malfunction of an oracle. Governance, tokenomics, and audits, that's the same for all the DeFi projects, so fundamentals. And if there are any circuit breakers, so what happens at Black Swan events? For example, what happens if FTX goes down? Or what happens if Uni token goes up like 50% within minutes or hours? So to understand also what happens in the critical moments, because oracles have one job, like be robust and be up. So this is like the most important, and to understand like how they behave when truly they are pushed to the limits, because they cannot like fail in these moments. I wanted to create the Oracle comparison table, but I haven't managed to, like the time didn't allow me. But soon on Redstone, profile on Twitter, like Redstone_DeFi, I'm going to finish that and publish over there so that users have better understanding of like how Chainlink, Redstone, PIF, API-free, and other oracles actually compare to each other and what are the major aspects that they differentiate from each other. Because also for you to understand, our approach is that actually all of the names that I mentioned right now are doing fantastic job in their own fields. And in my opinion, it's super important to keep appreciating, like for example, Chainlink for delivering what they've done so far, PIF also what they've done, and also shout out if you see an oracle that is a bit more shady, like making airdrop promises or I know advertising cars. I'm not going to show names right now, but you can probably check in Google like oracle that promotes getting a car or something like that. When the code is not speaking for the oracle, rather the marketing campaign, then you have to know that something is cooking in the back. And at the very end, I would like to invite each and every of you to ETH Warsaw conference and hackathon that is going to happen. Oh, this year it's going to be beginning of September, from the 2nd to the 9th of September at University and Warsaw University of Technology. Invite all of you very much over there. And thanks a lot for spending with me these 45 minutes. I hope you enjoyed it and learned something. And I don't know if there is like an option to get questions over here or not. I don't think so. If anyone wants to ask a question, raise your hand. OK, there is a question. Yeah, but I don't know. Is there another mic? OK. All right, so it's pretty not comfortable over here to ask questions. So thank you a lot. And if anyone would like to ask anything, I'm going to be here next to the stage. Thank you a lot.